course, I don't know all the teams. So I know the Eindhoven teams. Actually, I don't even know all the Eindhoven teams.
Oh.
So I'm the coach of 3 of the teams, essentially. So I know them from my honors track. So we do an honors track on competitive programming and problem solving in this university. And basically they are students or old or ex-students of this program. So that's how I know them. I mean, can they win? It's a good question. I cannot say for sure at this point. If I'm looking at the preliminaries, then basically it's more likely that a team from Delft is going to be high.
Teams from Delft. And so I think there was as I know, teams who are participating on World Final, there also should be strong teams from Leiden University.
Exactly.
And maybe some else.
I mean, there's usually the usual suspects indeed. So I don't remember who actually went to the World Finals last year.
I think there was a Delft team and Leiden team.
Okay. Yeah, so Delft and Leiden are definitely the teams to watch. Usually also we have good teams from Utrecht. And sometimes Twente. It differs. Also, Belgian teams usually perform quite well at the BAPC.
Oh, okay. Let's see. So I think the easiest problems are not too hard.
That is true.
This year, I think I've seen a problem set a bit. And the easiest problems should be problem E and problem F.
Oh, we can talk about problems now. I don't have a problem set with me, but I know the problems.
That's good that you didn't see it.
I have seen the problems.
Oh, okay. So I hope we'll see submissions quite soon. It can be a small trap to the teams that like you mostly start in like one person starting from the end, one from the other end. And
Yeah, so
when it's E and F, it's can be a small trap. For
yeah,
teams.
because the first and the last problem are not the easiest.
Yes, definitely. Okay, so how could you estimate the first submission? Like, is it 5 minutes, 10 minutes?
Yeah, I have to remember do we have a problem set here? No?
Well, not really sure.
Our person is gone, yes.
I think that was a problem about locating an angle, like northwest and stuff like. Okay, I think we need.
Oh yeah,
a
that
problem
was,
set.
was that problem? I don't think that one is that.
I'm not sure
easy.
if the coaches who are looking for the stream have the problem set now.
I don't know. Peter, do we have a problem set?
So and can. Okay.
Okay, I will look at the problem set on my phone.
No.
No?
No. So we can. We should not talk.
Oh, we're not allowed to talk about the problem set?
For 30 minutes.
Okay.
So you already ruined this.
Okay. Maybe not too much, I hope.
No.
Okay. So we'll wait the practice contest. Okay, that's okay.
But yeah, I mean, usually you expect
Oh,
some
anyway,
submission.
I hope there would be submissions in first 30 minutes.
I mean, there must be something.
And
So
they will revolve
typically
the simplest problems.
within 5 minutes, there should be something.
Okay, that would be nice.
Yes.
Like, we have as you see, we have some overlay stuff in the stream. It will show us the team submissions. At some points, it will show us scoreboards and some other contest-related information. Now it should soon show the contest timer. It's not showing it yet, but it will. I hope it will show it soon. Also, you can send some questions to the comment. I try to check them to the stream comments.
You mean all of our viewers?
Well, I hope we'll have more people in some point. Okay, so maybe we can just talk about your experience. Why you are coaching for ICPC?
I mean, I've been doing this for a very long time. So when I was a student, which was back in 2003, I sort of rolled into the competition. So I knew some students that did this more regularly before. And then I just joined the competition. And I really enjoyed it. So I started training, get better. But as a student, I mean, I did perform quite well, but I never really had any training program or something like that. So when I became a PhD student at this university, I decided that I wanted to help other students get better. So then I started actually training and coaching students. So that went quite well. I think at some point we also won the BAPC with a team, and we also went to the World Finals. And actually since then, so I've been away for 2 years since then, but I've come back as an assistant professor and now associate professor, and I've decided to continue doing something with these contests. So that's why in 2015, I think, I set up a program, an honors program, where they basically learn about programming contests, algorithmic programming, but also other types of programming contests. And they basically have like a program to follow to train for these things and to participate.
That's cool. I think that many people. Well, are we? Can you please check that? Okay. Okay. So, what? So you said that they were not the only coach for Eindhoven teams. Some teams who are there are some more people.
Okay,
working
so
on that?
to be honest, so we had our preliminary contest a month ago, and there were several teams that I've never seen before. So basically, I don't know them.
Probably.
So that I think there's one team of first year students, which of course I will talk to actually join my program.
Nice.
But
we have a first submission, and it's on problem E.
well, it's not surprising.
That's one of the easiest problem. You can we probably can't discuss it
No,
now.
we can discuss it.
But I hope we will have some judges after the mirror contest would start, and we'll discuss problems with them.
Are they going to explain all the problems here? We will see. I mean, there's a nice board here.
Yeah, that's the point. Okay, so we got the problem, and what is it? Is Rook? It's probably you can decipher it better than me. It's some
This is
which is
Groningen, right?
university.
I think this is Groningen.
Sorry,
Groningen.
Groningen. Okay, and so, well, do you know something about that team?
So Groningen is funny in the sense that I've talked to the coaches of Groningen last year, and they were actually quite small as a community also of people participating in these contests, and they wanted to make that larger. So I actually helped them to set up a new course, new program to attract more students. So actually I'm giving a guest lecture next week.
Should be really nice. I've been in Groningen. It's a nice city.
Mm-hmm. Yeah, we've also been there. I think in 2009. It's a bit far from here.
And we have one more submission from
that's wrong.
From the team, and that's wrong.
It's from Amsterdam.
So it's from Amsterdam. I don't remember the name. It's
the Vrije Universiteit.
Vrije University. Okay, and so for those who are not familiar with what's happening on, teams have 12 problems, and they need to submit some code which solves the problem. And it can be correct, and if it's puzzle test, which happened to the first submission we've seen, and it can be incorrect if something, and exactly that's WA means wrong answer. It means that team produced some output for some test, but it was wrong. That's happened. Hope the team got this verdict, and hope they're working on fixing it. It should not be hard. It's an easy problem, but soon we'll see more submissions with.
That's to be expected.
Cases? Well, that's not much to
maybe a different question. So since you are our new host, so can you say something about yourself? Because
I'm working on ICPC live team, and now I moved to Netherlands a couple of months ago. Well, actually half a year ago.
So where did you move?
I'm now living in Amsterdam, and so I came to find a local ICPC community to discover it, to get known to it.
So what is your background?
I'm ICPC World Champion 2014.
2014. Very
good.
Yeah,
we have 3 submissions right now.
I think it's catching on that easy.
Yeah, so teams got one team solved problem E. They solved it. They see that, and so we have 2 teams
from Delft
solved this first attempt. and one team who got it for the second attempt. So when you getting wrong submission and then getting a correct one, you getting extra 20 penalty minutes. So this team, as you can see in the queue, it has it's force. So maybe we can enable some scoreboard to check what's going. Okay, we have a small scoreboard and a big one now. By the way, at some point, teams will start to receive the balloons for their problems. One team has some Unicode problems.
Unicode problems? I mean, we have piece of cake from Eindhoven.
Yeah, we have piece of cake with no Unicode problems, and a team with flags with Unicode problems.
This is one of my teams.
Okay,
for now.
So, but cake was easy enough, but
yes, other things.
O flag was not easy enough for us. And so you can see the colors of the balloons. Team will receive for each problem. So for problem E, they should receive a yellow balloon. And I hope we will soon see some yellow balloons on the background when we see teams. Also in scoreboard, you can see this star near one team, which means that this team was the first who solved this problem. So we'll see more interesting stuff in the problem, and I think we should see one team with +1 instead of plus when it's scrolled back. Yeah, and so you can see this yellow balloon on the background.
Yep, we see Kati hanging it up.
Yeah, and so we have team from Amsterdam University which have +1. This means that they got one incorrect submission but solved the problem after it.
Okay, so going back to you. So you say you've become world champion in 2014?
Yeah.
Can you maybe say what it takes to become world champion?
It takes a lot of time.
So is it a lot of training or?
It's a lot of different stuff. Like you need to participate in a lot. So for me personally, I started when I was in 8th grade in school. Mm-hmm. This was some local training by students of Saratov University. You probably even don't know where it is. No. It's some middle-sized city on Volga in Russia. Okay, so then I participated a lot in local competitions and started participating, but it went quite well. So I was in 2011 in team on IOI and got 3rd place on it.
Uh-huh.
It was in Thailand, I think, in 2011. So since that, I was participating in school competitions, in organizing school competitions, and participating as a student. So then you train a lot. We trained a lot. Well, it's about different stuff. Like you need some luck. You need some. You need to love this, first of all.
That's most important.
First of all, you need to love solving problems. And then the question is how much time do you able to spend on it? I
mean, I just wonder how much time does it need for a world champion?
Well, I think it was like the year before we just got like something like 5-hour contests a week. And that's not including like code forces and other stuff like that. So it was.
So it's really intense.
In fact, it's full-time job.
Yeah.
It's need to be understood.
Yeah, I mean that's what it takes, guys.
And we have one more first to solve. I think
problem B.
Team solved problem B.
This is Utrecht.
And one other team attempted at problem F. So the team with problems with Unicode. I think they tried to encode the word Unicode in it. So it's like United Nations flag. IN is, I'm not sure which flag it should be.
That's a good question.
I'm not good in geography. And then there is some emoji which
I think it's Ivory Coast or something.
It's some emoji of something with country code IN. I don't sure what is it.
Wait, it's changing.
Oh yeah, it's fixed. Yeah, so that's the problem is this emoji seems to be a Google Chrome parser bug, which is not ready to one symbol emoji at this point. So Unicode is hard, and it's exactly what this team tries to say to us, I think. And also we have a submission on problem J, which I don't think to be easy one, but Delft's university team has another opinion. Yeah.
Shame.
So also
we cannot discuss the problems. But I'm trying to remember.
Also we got some medals. Some medals highlighting. Now the first 4 teams would get a gold medal, which is highlighted by gold. The second 4 teams would get silver medal, which is highlighted with silver. And next 4 teams would get a bronze medal, which is not highlighted by bronze yet because they have 0 submissions. And they can't get a medal if they have 0 ridiculous. Submissions. So we'll wait until they solve something. And another team is trying to solve problem L, which, in my opinion, was of the hardest problem in the problem set.
Is that the last one? Or is that
yeah, I think it's the last one.
I mean, it can be really easy if you know what you're doing.
Well, it's scary.
Well, so my background is in computational geometry.
Okay, let's make a bit easier. Okay, so we'll discuss. I hope we'll discuss it later. And we have a bunch of wrong submissions of problem E.
Yes.
So we can now see another verdict. Your submission can not only be failed because of wrong answer, which means that you produce something but it's wrong, but only it can fail with runtime error, which is encoded as RE. And this means that your code even failed to produce output.
It crashed.
It's crashed in some sense of it. So probably that can be just small mistype in an input parsing.
Yeah,
or something
it can
like
be anything.
that. Runtime errors
bounds
are mostly much easier to fix than other errors.
I mean, wrong answer is the worst. That is
wrong answer is the worst because
that's nothing.
You're just wrong.
Yeah, it's wrong.
And also we have a team preparing on problem A. Maybe we can have an overview on scoreboard to see which or maybe there is statistics which problems are working on it. Yeah, we can see it. So we can see then one team is attempting on problem A and did not succeed it. One teams are attempting on problems F, J, and L, and neither of them succeed. And one team attempted a problem B and succeed with it. And 7 teams attempted problem E and succeed with it, while 6 teams didn't succeed with it yet, but hope will succeed soon. And also we see more and more yellow balloons.
Yep. I think that's problem E. So.
And also we should see one red balloon. But probably it's in some other room.
Well, a pink one. Oh, no, sorry, the red.
No, pink
red.
one is for problem A.
A, yes. Okay. It's probably so do we have only one room that we're seeing? Or is this
no, I think we are able to move between them.
Oh, yeah, because that would be nice.
But that's not happening instantly.
Oh, there we go.
So okay, we can see on us.
Exciting.
And so how many times did your teams pass to World Finals?
Only once.
Only once.
One of my teams.
And it was when it happened?
This was in 2011, I think.
2011.
Yes, so it's a while back. It was a team. So when they first participated, I was also participating in the NWork. This is the European contest. And then basically I saw that they had potential. I did beat them in that contest, but after that I was ineligible for my own participation. So then I started to coach them.
Okay.
And they were very eager to get better. And they also had some IOI experience. So I was able to get them to train very, very well, and they actually made it to the World Finals.
Yeah, that's nice. I think that there's very different history. I know people who started very early and then made well, and I know other people who started quite late and progressed much. That especially happens when you have some other related experience. For example, one of my team members started in only at the end of 11th grade. So mostly in first courses of university, but he had a lot of mathematical Olympiad experience, which helps a lot.
That helps a lot, definitely. I mean, you want to have these different skills. So also the team that I had that went to the World Finals had 1 mathematician and 2 programmers. And then you really have this combination of skills.
Yeah, I think that it can... Oh, we have back our queue, so we can see one more team solving problem E, and
Yes.
as it got 11th place, I can suggest that at least 11
It is
teams.
bronze now.
Well,
It's a dirty brown, sure, but
yeah, so it's
supposedly
showing
bronze.
bronze. So we have 11 teams solve at least one problem right now, which is nice, and a lot of other teams attempting.
I think it's really waiting for the first team to solve too.
Yes, I think we should have it soon, because at least teams have shown that problem B is not very hard.
It is true. That is true.
It should not be too hard.
It should
Yes.
should be fairly straightforward.
And so probably most of teams who are already solved problem E worked on problem B, and I think some of them should get it soon. Okay, so you said that teams like have people who specialized on this, on some
Yeah.
on some other work. And what can you say about your teams this year? Do they have like special mathematicians or special coders? For example, I can tell about my team. It was like we have a person who coded like 90% of all problems. And to be honest, for the whole ICPC season I coded exactly one problem. It was the easiest problem on World Finals.
Okay.
Just because it was faster to code it than tell the statement to Yegor.
So you were the problem solver.
Well, I was much more debugger.
Debugger.
Like we did some strange stuff, like, I don't know, when Yegor has some problems, he just printed the code, I deal with what's going on, and he just gone to the next problem. And it works really well.
So you were really good at reading his code then.
Yes, but probably that's won't work for most teams. So what's
No. This is
your
a difficult skill. Let's see. So I have one team that is basically my former honor students, and they have also mathematicians in there. So they also have one member that does both mathematics and computer science, and there's one computer science student and one mathematics student. So it's a nice combination of different ones. And the other teams, those are current honor students that I have, and they're also different. So some people have some mathematics experience as well, but one of the teams has all computer scientists, but they do have some background. So they are Romanian, at least some. I think all of them. I'm not sure. So they usually have some more math background already when they come into the university.
math background really helps a lot.
Yeah.
Like, I don't think that the math background itself, but like, I think maybe school children who are taught math a lot can be just more get used to some abstract stuff we need.
Well, so you see the different backgrounds, right? So if you see students coming from different universities, they have different skills that they're good at. So people from Romania have a very much more hardcore math and computer science experience coming from the high school as that we have. I mean,
That's sometimes getting even. I think we have a team who got two. First team, it's as they solved problem E. I would suggest that was exactly the team who solved B first.
Yes.
And so we can now to take a look on a scoreboard. Maybe we can suggest if are these teams expected to be strong ones, but unfortunately it's scrolled a bit.
Yeah, I think it's a bit too early to tell. These are of course the easy problems.
But at least we have some teams we can discuss. If you know something about them, it would be nice. Also, you can see such a yellow cells in the scoreboard. It means that these teams that send it a submission which is not evaluated yet, and when it solved it flies up. And we will see much more of such yellow cells on the last hour, because now it only happens when team is submitted but the problem is not evaluated yet. While on the last hour we will only receive these yellow cells and nothing more.
Yeah. I mean, it's usually good for teams to have the easy problems knocked out quickly.
Yeah,
but given the problem set, I mean, there's going to be a large set of, decently hard problems. And that's where you really have to shine, right? Getting through those problems is really going to decide who has most time to actually get to the really hard ones.
Okay, maybe you can say something about our top team. First team?
It's UU? I wouldn't dare because I don't know all the teams that well.
Okay, maybe at least know what is UU.
It is Utrecht, indeed.
It's Utrecht University.
So actually, one of the jury members that is in this competition, who's also a coach for one of the Utrecht teams, maybe for this team, I'm not sure, was actually a former student of mine in my honors track as well. And he actually made it to the World Finals last year. And also he's going to the coming World Finals.
Really nice.
So I don't really count it as my team because he went to a different university for his master's and then got to the World Finals. But it is at least my former student.
Anyway, that's nice.
Yeah, so maybe he's coaching that team. I'm not sure. So we should ask him when he comes by.
Okay. And so we have a lot of teams, one of the teams who solved in 6 minutes problem E, and they are not sending anything for 20 minutes now. So, we have some teams starting to work on problem B. Like it's...
Yeah. They're catching on.
So I think it's I don't know, unfortunately, this university names.
You mean the Louvain?
It's some Belgium university.
Yeah, that's a Belgian university.
Okay. So they're starting with problem B. I'm not sure if they didn't solve problem E yet.
I guess not, because they have solved 0.
Okay,
so but maybe they've worked on E.
Well, yeah, the good stuff about having 3 people that you can work on the problems in parallel. Like when you got this wrong answer, you can print
exactly
and check what's going on the paper. That's what I mostly do in the contest.
It's your skill, yes.
Yes, and then to solve the problem and write code for other problem by other team member.
So would you be able to also do this skill with other people having coded something?
Yes, it's quite like, well, that's...
I mean, so you might have been attuned to Igor's coding, right?
Inconsistencies, finding some, thinking about corner cases. And well, I think that's one of really important stuff that ICPC produces to real work.
Yeah.
Like, maybe we can...
No, I agree. So, I mean, given that I teach this kind of stuff, I look at many people's different codes. And nowadays I'm very good at saying, there's the mistake.
That's also... Oh, and we have... Well, we have team.
Ooh,
we have team with Unicode problems who have solved problem I.
Oh,
which I don't remember what exactly it was about and how easy it is.
No, you're almost at half an hour, right?
Okay, it's not really a hard problem.
Do you remember the name?
Let's wait for 2 more minutes.
We can wait for 2 more minutes, sure.
Okay, but that was like. Not the easiest problem, but definitely in the first half.
I would have to look at it.
So now we have 3 problems solved. This problem B, problem E, and problem I.
So then we're quickly going to go to 3 solved, hopefully.
So probably maybe the university. So which is this? It's University of Amsterdam, or what is it?
Yeah, UVA is the University of Amsterdam.
Okay, so they have probably maybe have something prepared for problem B. Also, we have one more team who solves problem I, and they have smaller penalty time because they were very fast on problem E. So the penalty time is just sum of points when you submit it. This is some strange stuff, but it's quite traditional.
Yeah, I mean, that makes sense.
It makes sense. It's like how much did you lead one over the other team, which... Why not?
I mean, you need to have some sort of...
you need to have some tiebreaker, and that's not the worst one.
No, I like that one. It also basically suggests that you should be a little bit careful when you're programming and also try to start with the easy ones.
Yes.
So build up to the hard ones.
Well, some teams do different stuff. Like, for example, in World Finals, you got prizes for first to solve some problems.
Well, yeah.
So some teams which think that, okay, we are not really competing for medals, but we have but we can try to steal the prize.
I've never thought about that, but of course,
I think I heard about a couple of teams doing that. That's not a massive story, but sometimes it happens.
Yeah, of course, if you want to become world champion, then of course this should be the right strategy.
Different. Well, I think this prize is like quite nice, but not life changing.
No. So did you get any life changing prizes from becoming world champion?
Not really.
No.
Well, let's make you a bit known, which makes it a bit easier to have some work, but nothing else.
So what kind of work do you do now?
I'm working on Kotlin project, but probably that can be sort of some kind of product placement, which is not good. So I'm not sure if we have teams solving problems on Kotlin, but
I heard there were some issues with Kotlin, but yes, apparently there are.
so probably at least someone tried to submit something on Kotlin on the practice session.
Indeed. Okay, let's look at the problems.
Yes, and we have a bunch of submissions on problem F
Problem
from
F. Okay,
different
but
teams,
so
which was thought as the second easiest one for me.
okay, so E definitely is easy. That's just some basic
Again,
computation. That's
so probably
straightforward.
we can we somehow maybe show part of statement in stream? Probably not. Not easy.
It's not gonna be easy, no. But
So
of
we
course, there are
can
gonna be
just-
jury members later who explain all of
Okay.
this. F, yeah, it is not hard, but it's a little
So
bit more
problem
annoying.
E is basically just for understanding, like you get some formulas you need to deal with, and just be accurate with not dividing by zero,
Yeah,
stuff
just
like that.
some basics you have to get right. You know.
Oh, I think that one team solved problem F, and we have the fourth problem which
Oh, yeah.
at least one team solved.
I mean, F is not hard. It's just
Yeah, it's-
a little bit more work to actually produce.
So can you maybe explain the statement of the problem?
Maybe you can.
Like- So well, there is some kind of notation which everyone knows, like there is north, west, east, and south, and there is stuff like northwest, northeast, and southeast, and etc. And so this notation can be continued to more detailed. And so the problem F is basically to parse this notation, which is formally described in statement, and to do something simple in it, like maybe having I don't know, middle of the segment or something like that. I'm not sure. But basically just to deal with this notation.
I mean, yeah, the whole point is converting one of these strings to
I'm
to
not
an angle.
sure.
right?
So but maybe we could check a scoreboard now to see. We have
the
a bunch of
scoreboards.
teams with two problems which are different. So the problem E is definitely the easiest one according to the teams, while others have different options, and some teams are working on problems which are not solved yet. So probably, well, I think the problem set itself is like it's quite goes to the different places. So there are a lot of problems of mostly same difficulty level,
Yeah.
and
yeah.
you can choose one you like, which is always great. So I think the hardest problem are problem G,
G is a
and-
bit annoying, yes.
and I think no one tried to solve it yet.
No, I'm not expecting that to happen.
Well, and the other one which looks hard, I think is problem J. Well, I think it's
J
be honest,
is- it's not hard.
I'm not agree with judges. I think it's easier than the
No,
last one.
I mean, you have to be able to analyze this properly, but it's actually very easy
yes.
once you.
So that. Oh, by the way, how long Bob has interactive problems? We have two interactive problems in this problem set.
Ooh,
World Finals has its first interactive problem, I think, last year.
really? Was that the
And-
first time?
And there was an interactive problem in practice session in Porto in 2019.
Okay.
So
So how long we have? I must admit. So first of all, I don't know exactly, but second of all, this has been changing. So there was a very old contest. We had interactive problems.
okay, yeah, we have one more solution for problem B.
Ah,
So we have quite a lot of teams with solving two problems right now. I
yeah,
think we have 5 and more to come. So waiting for 3.
exactly. No, I mean we had interactive problems a long time ago. Then they went away for a while, and then they came back. So, and we have had that for several years. We have interactive problems now again. So.
Okay, that's this interactive, like let's allow some different aspects of programming.
Yeah,
Like when you are solving typical competitive programming problems, they are mostly about optimizing time, which is not the only stuff you need to do. Like,
yeah. I remember when so at some point I was jury in 2011 or something like this, and then we also made an interactive problem, and they're kind of fun. They sort of
yeah, that's
They
a
require a
that's
different
always a
skill.
fun for jury because it's require much more work.
yeah,
Be
yeah, yeah. You have to
much
set
more
up
careful
yeah.
to set up everything correctly.
But it is fun. It has
adds some
creativity. And here, this one is also a very interesting one.
So
it's easy to solve, but
can we already discuss it?
I mean, I shouldn't explain things for the jury themselves because I only
that
know.
Would be better. They at least.
I know the problems. I know how to solve it probably, but not
I'm
exactly.
Not sure what what did they mean. So it would be nice to have some jury member. I hope we will have some soon.
Yeah, we'll ask Peter soon to find a jury member. That would be nice too.
Well, I talked to a couple of them. They said that they would be able to come when they check everything is going well, which is of course much more important.
Yep.
So we have one more team solve problem B, and that's first problem for them. So why not?
I mean, B is just one of the easiest geometric problems I've ever seen. So
well, B is you need to understand some model. You need some mathematical culture for it. I call it like that.
You need to compute an angle. I mean, it's not complicated.
Oh yes, but just understand what you're asking for.
Yeah, sure. But other than that, it's so easy.
Yeah, so when you understand what you're asked for, that's easy. But I think, and maybe, you say that you have an experience in geometry. But many teams
they do dislike the geometry.
Well, they just not only don't like that. I think a lot of teams just when see them picture like that will just throw this problem away.
I know. You get this sort of sentiment that no, not geometry. Oh, too much work. I mean, for me, it's different. I mean, I really like geometry. So also, I know that it's a pain to program sometimes, but it's a pain I like because it gives you something that you can actually see.
Yeah,
I like that.
That has a problem. Like a lot of stuff you're asked in competitive programming, problems are too abstract. Like why would something want to compute this?
Exactly.
While geometry problems are often make some sense.
Yes. But there's more geometry in here.
I think we have a 3D geometry.
Yeah, so that one was fun.
In problem L, which is not too hard, but I think it's terrifying. Like you read the problem.
For this one, so this is doable but hard if you give them a fixed point set. With the randomized point set, you can do this easier.
Yeah, that's so. Well, I'm not really sure what exactly was meant by jury. I know several algorithms to do that. Yes. Each of them.
So the real algorithms, of course, I know all the actual algorithms that exist. So for a fixed point set where you can actually make very bad cases, then it becomes complicated.
Okay.
But if you have some sort of randomized model, you can use that to.
Well, I think some stuff like random line projection should work really well for random point sets.
For random point sets, yes, that would definitely work.
Almost everything should work well on random point sets, but
but you have to be a little bit careful.
You need to test it. So,
I think in this case a bucketing approach is easiest.
Bucketing, okay, let's make some.
But I don't know what the jury intended as a solution.
Well, I think jury intended just to do something.
Yeah,
like it's.
I mean, you actually have many options.
Well, I was a jury member on many competitions, and it's always nice when you understand that problem can be solved with different approaches. So everyone could choose what they like. So
I think especially problem L has many different approaches.
Yeah, that's always nice to have them.
Yeah.
So do we have something interesting in scoreboards right now? I think we have already around 30 teams who solved at least one problem, which is
we're getting somewhere.
And
look at that, Eindhoven's at the top.
So piece of pie. There.
It's a piece of cake, but sure.
It's a piece of cake. Okay. So, thank them a lot. I have to support the emojis in the scoreboard.
Yeah, definitely.
That was not work from stretch, especially as we see with more complex cases.
Yes.
So that's So I hope they would have luck to continue doing well. They have a good start, which is a big deal. Anyway, it helps you to have good penalty time. That means that someone needs to overperform you to the whole problem, which is much harder.
Yes. I guess the first team should now start on B quickly. And if they will not solve this, I will scream at them.
Well,
I've taught them this kind of stuff. So.
okay, that's nice. And so, what do you think about other problems they have to be solved?
I must say,
So they have solved E and I think.
Yeah. So E is of course trivial. I is a little bit more
Well,
parsing.
it's just understand what do you need.
I mean, you have to parse this somehow.
So you have to parse the input. You have some graph stuff, like you need some depth first search or something like
whatever.
that.
I think here you could probably do like.
You just need to have some basic graph algorithms.
Yeah.
But still, you need to be accurate on that. Also, I'm not sure if you need to deal with precision issues.
I think precision issues might play a role.
Well, I think that should not be an issue as well. The constraints are set up like you should have no problems if you're using double type, because
I would hope so.
But I'm really scared every time when you have to
play with floating points.
Yeah. Also, I think there can be problems like you fail to output them correctly.
Yeah.
But that problems has a small tweak, which is quite. I saw some problems with that, and it was tricky for a lot of participants.
So
they asked for a relative error of. Not absolute a relative error as most of competitive programming problems are, but it's only relative.
Yes.
It means that if you try to output like 10 in minus 30s, you need to output it, not 0. Because when you output 0, you got absolute a relative error of infinity.
Yes.
So that can be tricky.
It is indeed tricky. So, yeah. I mean, they have to make sure you get this right. But that's the main problem with I think.
Yeah, I think so. But that's probably, it's mostly out of scope of competitive programming.
Yes.
You need to, and that's good. Because it's
real life.
Because first of all, it's real life. And second, you learn something on contests, which is always great. Like you learn that double is hard. Floating point is always an issue.
Yeah.
Okay, so and what other problems are already solved? I think
that's mostly it.
So,
I mean, that basically covers all the relatively easy problems, and then we get into the harder ones.
Well, I think there are one more relatively.
Which one do you think is
problem? I think
problem D? Maybe.
Problem D is relatively
yes, problem
easy.
D is also but you have to parse this whole question because it's hard to understand.
Yeah, well, it requires some complex model.
Yeah.
In your head.
But once you see what the problem is, it's very easy.
Well, it's required. Well, I think it was one of the problems I decided to postpone when I read the whole problem set. I just read it, some problems you just immediately got, like problem E. You read it and, I just need to implement what I asked for.
Yeah, so I think for this problem, this is one of the problems that when I proofread it, I basically said, maybe you should make this more clear because is this how you interpret it?
I don't know how to solve it right now. I need to postpone it. So that's not a trivial one.
It's not a trivial one, but it's once you see it, it's very easy to program.
And we can talk about the problem L, which is try to be solved by some of teams, and we can have a new verdict. We have a time limit, which means that each problem has some limit of how much CPU time you can use to solve it. And this means that in one of tests, the program was running too long, and so it wasn't allowed to run anymore. And the team receives this, and that's a hard verdict to deal with because, what's next?
Well, yeah, I mean, if they went for the very easy solution to L, that is definitely not fast enough. This is buying all pairs, then they will run into this.
We'll see. Okay. So we had a submission from this time limit, and it's just trying to check all pairs, which is definitely not enough for this problem. So, could have guessed. I hope they will be able to deal with it at some point, somehow. With some smarter
they have
solution.
to come up with better ideas. But this is from Groningen, which is fun because I'm going to give a guest lecture to Groningen on Thursday on geometry.
Okay, that's a bit unlucky for them.
Yeah, it's a bit late.
That's-
So maybe we should have planned this earlier. Sorry, guys.
Probably you shouldn't, especially if you know. Okay, so we have one more team solving 2, and still have no team solving 3.
Nope. I mean, it takes some time, I guess.
Takes some time.
I mean, they're not all as fast as people at the World Finals. This is
They shouldn't be.
no.
The problems here are much easier than World Finals.
Obviously, yes.
Well, World Finals really have implementational.
Yeah, they
problems.
require more work.
They
Definitely.
require more work a lot. They're not much more complex you don't need more complex idea, but you need to deal with more details. And
I agree.
etc.
Those are usually just very annoying to deal with.
Well, not always, but
Yeah.
it happens. Okay, so maybe we can have one more overview on scoreboards.
Yeah, so how is this looking?
How it's looking now.
I mean,
So-
we're very happy to see Eindhoven at the top.
So we
and then we
still
see Utrecht. And Delft is a bit staying behind.
So mostly, one more team trying to solve F. Okay. So we see that several problems are attempted and solved.
Yep.
Maybe we think we need to highlight which problems are already solved. It would be nice. I'll think about it next time. Okay, and so we can see that top teams are distributed between problem B, problem F, and problem I, which are really 4 easiest problems. And so probably we can get 4 quite fast. Like people know what to work on. So work on third problem, they solve it, and they should be ready to solve the 4th one because they are shown which one it should be.
Yeah, and I think that after that we're gonna see who's really gonna probably win the contest, because that's when you get to the harder problems, and if you get those well, then
Maybe. And so we can see that we have more than 2/3 of teams solve at least one problem, which is always nice to have.
yeah. We see one team that is
Well, we have one team which has solved one problem, but not problem E.
so that
But
they still have some options.
have good perspective. They have good chances to come up with second one because E is much easier than everything else.
So what's happening to Twente? So
Happening to what?
if you see Twente at the bottom, like 5 teams with nothing. So
Well, I hope they will.
I mean, maybe they're just too tired because they had to come all the way from Twente.
Well,
but,
maybe they didn't come. Are you sure they?
I also heard there was some issues with teams from Twente coming, but
So maybe some teams just didn't come and we don't
Yeah.
know about that.
we don't know.
Yeah, it would be nice. Okay. We have one more team solved problem B. So it looks like teams think that problem B is a bit easier than problems E, F, and I. Maybe it's happened because it was solved earlier.
Yeah, I mean, E has this annoying issues. You also have to make sure that you output enough precision,
Well,
and
but
that you.
probably you don't have any reason to.
But
You
yeah,
just need to not divide by 0 somewhere. Probably
maybe if
that's-
you're using integers to read it in and add them up, then you're getting a problem. But
Okay.
other than that,
Thank you, Peter.
yes, at some point Peter should also find a replacement for me, because otherwise we're always talking to the same person.
Yeah, I hope we will have some of judges soon.
Yeah,
And
sure.
also, maybe you can, if there is someone you're interested in, probably you can write it somewhere, and we'll try to deal with it. Not sure we will be able, but if you know that someone is on site,
I mean, I think it would be nice at least for the jury to explain some
yeah,
problems.
I think that's
If
would
you
be
cannot
the
find them,
most-
I can also explain them, but I can only explain
well,
my version.
explaining when you explain the problem solution, it's always much better when you actually wrote it.
Exactly. I
And jury
agree.
did wrote
Yeah.
the solutions, coded them, and so you understand much more details.
Exactly.
Like you understand the high view. To understand the high view.
You
of
also
the
know what
solution.
can go wrong, basically.
Yeah. So while understanding the high view on solution, just thinking of the problem is enough. For details, it's always better to code.
Yes, I agree. Some balloons we see
Yeah.
here.
So we can see the balloons. So we have yellow ones for problem E, which almost every team has already. We can see a small red balloon on the back, which I think is for problem B.
I mean, we do see the nice ICPC colors, right?
Yes, so that's one you need to assign. That's a really important stuff. Which problems are assigned to which balloon color?
I think so.
Because like you have not too many problems, which would be really need for many teams. And also, well, I think World Finals have some special balloon for first to solve.
Do we see a third solution?
We have a team with
there's
team
Delft.
from Delft with 3 problems.
Now they're coming, Delft.
I'm not sure which one they already solved.
No, but they're going with F. So
They come with F, so they probably solve either B or I in before. But
if only we could switch to the scoreboard, right?
yes, but unfortunately, I'm not able to enable it. We probably need to fix it. So I would be able to manage it too. That's okay.
Yes. There's not enough staff here to
Well, that's okay. Of course, the competition itself is much more important than the stream.
It is.
So the staff should first work on the competition. And also we think we have one of the top teams trying to solve problem F. And I think this is Utrecht University. Did I pronounce it correctly?
Yeah,
Okay.
that was good.
So they probably can get it soon. And they would have
Also
3
go to 3.
problems too. So I think we will see a lot of teams with 3
Yeah.
soon. And I hope 4 we need not wait much for the 4th problem. And then it may become trickier because you don't know what to solve next.
Yeah.
It's always nice when other teams tell you what
Exactly.
is able to solve.
So, which one would you solve next?
I'm not exactly sure. I think then D is quite easy.
Yeah.
Maybe C. which
See
is-
if you like dynamic programming, I guess.
Yes, if you're familiar with dynamic programming stuff and probability stuff, like
Exactly.
this-
Then you might like that one.
Exactly, this needs some background.
If you like graphs, you
I
can do
s-
H.
Yes, probably. Maybe you can go with J
If you like randomization.
if you like some
I
kind
mean,
of
for the
randomization.
mathematician, J is kind of fun.
Yes, so if you like kind of randomization, well, I think that's the best problem in my personal opinion here, because like you read it and you got what?
Yeah, how?
How can
is
it
this
be possible? Like it's
Yes.
just too. So I hope we'll got someone from jury to explain it.
Yeah. That would be nice. I mean, I don't know the exact probabilities that are involved, but
Well, I think that's mostly based on fact that the random permutation can't have too many records. I mean, elements which are greater than
Yes.
everything before, but
yeah, this comes from a backward analysis, basically.
yes, but what's next? The details are not really clear.
Well,
It should.
once you know that, then it's all
Yes,
a
but
matter of
it's-
finding the top.
Well, that means that it's enough for asymptotically correct solution, but constant details.
Yes, that's why you have to. Be
Yeah,
able
that's
to-
why you need to code this,
Yeah,
and that's why we need jury to explain this.
please, jury.
Okay, so we have one more team. Also, you can see then.
Oh,
if
so
you-
Delft has also been submitting to I.
but they are wrong. So
Yeah, so they're close to getting 4.
well, not sure. Like if the problem I is tricky. If you got this issue with too small numbers,
Yeah,
there are 2 problems. First of all, you need to think about it, which is untrivial. And second of all, you need to know how to solve
how to
it.
deal with it. Yeah,
Because, well,
yeah.
I'm not sure, for example, if it's even possible with cout. If stuff like cout set precision 1000 would work.
It's a good question. I mean, you would think that if you have doubles,
You have double, which is around 110 in minus 1300.
yeah, that should be fine, right?
Yeah, it should be fine, but how? That's the question.
Yeah.
So okay, I know how to do it with print. Like there is E specifier who do this, but probably team can just don't know that.
Yeah, so that could definitely be an issue. I think cout should also do scientific notation for some cases.
Well,
But yeah,
that's a problem.
yeah, I agree.
And I hope do you know if the team has some programming language documentation?
Yeah,
they
they
can
do
check.
they have references for the
So
languages.
that can be better, and that's an important skill. Probably skill of being able to read docs is much more important than everything else they train.
You mean the also Stack Overflow and stuff like that?
Well, docs in general sense.
Yeah. Oh,
So
and he's gone
preparing.
again. Can we see the scoreboard?
And will we have
I mean,
our
it's,
next
it's
guest
getting
soon?
interesting. So
In about the plan is in about 5 minutes. I think.
Okay, so
Sure.
we are planning to have the next guest in around 5 minutes. Thank you a lot, and maybe some final thoughts. Like, what do we have here? We have
yeah, so Delft
have-
was getting slowly started, but now we see that Delft
we
is
have
at top. So
we have 37 teams which solved at least one problem, and many teams who attempted their problem, and hope we'll get this soon. And so we have Delft in the third,
yeah, so Delft at
first
top,
place.
then Eindhoven, then we see that Utrecht has also some promising teams. So.
Yes, and hopefully all of them should soon come up with first 4 easy problems, and
Yeah.
then
And then we see the real contest.
the
get
contest
loose.
begins for them. Okay,
Oh.
so wrong answers. A lot of wrong answers on problem E.
Yeah,
Maybe we can ask jury for that. What's the catch? I just don't really see any catch in
So
problem
we
E.
see one of the Eindhoven teams is submitting many problems with all wrong answers. So they're doing something fundamentally wrong, it seems.
Oh, we have one more team with 3, and they
Yeah.
overcome Delft by penalty, and
Oh,
they
Utrecht.
quite big with quite big difference. Why it's so big? Probably
Because of
because Delft starts
the
not
wrong
so
answer.
fast, and there's quite a lot of wrong submissions.
Yeah.
That's a problem when you bad at start of the contest. You
It's hard to catch
solve
up.
one more problem more.
Yeah.
And that's not always possible.
Nope.
And so, what is your prediction? How many problems would be solved?
In this problem set, let's see, we have 12 problems.
So will
Some of these teams are very good, so I expect at least.
each problem be solved by at least one team?
So I find it hard to say. So, for example, problem G is hard to work out, but I think some heuristics might actually also work for
Yes,
G.
to be honest, I don't know how to solve it exactly. I have some ideas. I'm not sure if they are correct.
I know how to solve it exactly, but that one is not easy. But if you do some heuristic approaches, it might
that's-
actually be easier.
Okay, well, I hope we'll talk to jury about that. I think that's in fact this is multi-packet problem.
Yeah, I mean, you have
which is
to-
known to be NP hard. So what's
so-
happening?
So here the trick is, of course, that K is very small.
Yeah,
So you need to really.
so you need to some like
you need to apply some
14
rules.
in the 7.
Yeah, so basically the
approach.
idea is that you first have to break off the big one so that you can only get this at most K size stones.
And then,
And then you have to pack up pairs that you can show that it's also always optimal, and then you only
then
have,
you have not too much options. Okay,
and then you can do dynamic programming.
yeah, that's
It's a lot of work, but it's
well, it requires some trust in
Yes.
your intuition.
and actually proving that this is correct actually is quite tricky.
Proving if this is correct is quite tricky. Proving if this is fast enough is quite tricky.
Yeah,
Because you
yeah.
receive something strange and you need to understand what are the worst cases
so-
for you.
So people need to be very good for this one,
Yeah,
unless you
okay.
find some different heuristic strategy. I have seen different strategies that also work that are not the right solution. But at least,
Oh.
I mean, that was a strategy without an actual proof.
Oh yeah,
But yeah, that
when
can
when you're a
happen.
competitor, you are in a much better place than in jury because you don't
Yeah.
need to prove your solutions.
Exactly. So that's why it might be solved. But other than that, I think most problems are definitely solvable.
Okay.
A is annoying, I think.
And
but
how much would you think the top team would have?
I would say 11 or 12.
11. So you are saying that all except G or all problems would be solved by some
I
team?
mean, I think some might be hard. So like G is hard. L can be hard if you don't know what to do. A is annoying, I think, but maybe it depends on the data set they have.
Don't understand why it's hard, but maybe I'm missing some details. Well, probably we'll talk to jury member about this too.
Well, the question is, how do you want to solve A?
Like, why it's not just find 4 elements with given sum?
Yes, that is true. In quadratic time,
And
it's
it's
or
like-
n squared log n, I guess.
Well, Yeah, that's something like that. Maybe even n squared with
But
hash
you have to
table.
make sure that these are 4 distinct elements, right?
Okay, that's
That's the tricky part.
that's not too hard, but can be tricky.
And I think that working around that, so either this is not too necessary, and then you can just search around enough, and that is
Okay.
easy. But if you really have to do this specifically, it's difficult, I think.
that can be tricky. Yes. Probably this can
But we'll
be
see.
quite easily work around it by having no more than 4 of each value, and then just check all pairs, all valid pairs, or something like that.
That's some tricks that you can do, but then you have to use one of these
But
tricks.
that multiplies your solution time with 16,
Yeah.
which not really. Oh, okay. We have a jury member.
Excellent. He will explain stuff.
So
Yes, you have to. Yeah, this is your mic. Oh, just
we can probably. So how much time do you have? Okay, okay. We can probably introduce you first.
I mean, we'll.
Okay.
Continue. And ik geef het even.
Okay, sure. So
So
luckily, Ragnar will explain all of the problems
Thank
to
you
us,
a lot.
because otherwise we're just guessing, because he
Correct.
never told us the actual solutions.
Okay. Oh, we have one more problem solved. So team from Delft have solved problem C.
Ah, see, that was the dynamic programming one.
Yeah, that's
the
not
probability one.
too much, but requires. It's not too hard, but it requires some knowledge.
Yes, it requires setting up a good recursion
So
or recurrence, what you want to call it.
and also we
But we
have.
see that Rodbout also has
and
3.
also we have one more team with 3 problems,
Yeah.
which is nice too.
Yeah, it's getting more interesting now.
Okay, so I hope we'll have 4 soon.
Basically, je krijgt weer vakken van stoel going aan en dan.
So I should leave, right? Yeah.
Just keep talking and it will be fine.
Well, but you know,
Well, probably too many.
I'm sort of in the way.
So can you please introduce yourself?
Yeah, so hi all, I'm Ragnar. I am a longtime BFC jury member. I used to be head of jury, now I'm not head of jury anymore. But I worked on problem B. Well, I authored this problem. So I will talk a bit about this, I
This
think.
is one problem's already solved. So
Yes. Is that good or not?
yeah, that's perfect.
So this problem is called Bellevue. I came up with it on the island of Ischia. It's an island in front on the coast of Napoli. The picture you see I took there, it's the Mediterranean sunset, and the drawing is like a sketch of the island. So this completely natural inspiration, and we just had to like abstract it a bit to be suitable for the contest. Yeah, so let's see if I have some stuff to draw here. Is all of this in view? Yes, this should.
Yes, you can see what is going to
Yeah,
stream
okay, this should be
here.
fine. Okay, let me try to draw this picture. Okay, so we have some kind of island. Well, that's a promising start. So we have some kind of island, and we're asked to find the best viewing point. Let's make this a little bit different. So in this case, the best viewing point would be here, because the viewing point of the sea is this entire angle. So here on the left of the island we have C, and on the right of the island we have C. And we need to find the point on the island with the largest viewing angle of C. And so, for example, for this point, it would only be this angle, and for this point, it will be pretty much nothing. And I think it's not allowed to be at the start or the end of the island. So, a first thing you might do is determine the convex hull, and then just look at the angle between this point and the next point. So in this picture, that's actually kind of boring. So let's quickly draw another one. Something like this. You can do some kind of complicated quadratic. I guess you can do n log n algorithm to draw the convex hull, and then you can just iterate over it and compute all these angles between consecutive points and take the maximum over them. That works, but then you need to do a convex hull, which is kind of complicated and unnecessarily complicated in this case. So there's something nicer. Let's see if we can take some colors. In fact, it turns out that if, let's say we're here, and the point we see on the horizon is basically this one. It's not the start of the island. And in that case, it kind of implies that this point can never be optimal, because it would always be better to go here, because the viewing angle there will be at least as large. So that means that if you cannot see either the start or the end of the island, the point is never going to be optimal. So now we can just assume that from the optimal point, we can see the start. And like if we go back to our original case, it means that suppose this is the optimal point, then the angle will be this one, just to the start, or this one, to the end. And we also have to try this point, and it will be this angle, and we also have to try this point. In this case, we already know it's not going to be optimal, but we can kind of still compute the same angle, which will be this angle here. Even though it doesn't actually work. But we can replace this point by this one, and it will get larger, so that's fine.
But we do need to understand if we see the end of the island.
So it turns out we actually don't, because if we kind of assume that we cannot see the end of the island, we can replace it by the point on the horizon that we can see, and it will be better. So we can just kind of assume we see the end, even though we don't.
Okay.
So is this not equivalent to finding the first edge of the convex hull?
Yes, basically. That's exactly it, I guess, I'd say. So what we can do is we can just compute all these angles to the start and the end. And let's only look at this one. So if we compute this angle, actually it's kind of nice with this kind of Z angles thing from high school. This angle is going to be the same as this angle. And this angle is going to be the same as this angle. And this angle is going to be the same as a smaller one. So we can just sort all the points with their angle around the start and find the one with the maximal angle. Oh. And then we do the same around the end. We draw all these lines, find the one with the maximum angle, and then we take the maximum of this one and this one.
So in fact, this problem is kind of catch for the top teams. Like you see the problem, you say, hey, I know how to solve, how to write a convex hull, and just starting to write it, you waste a lot of time. While if you are maybe not so familiar with it,
if you think a bit about it,
you can think a bit more.
And simpler.
And if you think about the gift wrapping algorithm for convex hulls, this is the first step.
That's
and then you're done.
just
Right, yeah.
you just need to write the algorithm from convex hull and then throw away most
so
of the code.
the submissions I've seen to this problem, I think all of them just do this. They either do one for loop where they like take the maximum of this angle and this angle, or they once compare everything to the left point, then they reverse the array and you just do it exactly again and you take the maximum.
By the way, meanwhile, your team is coming up to the first place back.
Your team, not my team.
So most of teams solved problems E and problems F, which we kind of discussed already.
Okay.
Which are not too hard.
So my team did not solve B yet.
But maybe you can say why some what problems does the teams have with them?
With which
problems E and F, like
I think with E, many teams that we've seen so far forget the input case where everything is 0.
So they're trying to divide by 0.
Yeah, and you get just a lot of
nans.
nan or minus nan, whatever. It depends on the implementation, I guess.
It depends on.
Yeah.
Also, it depends on which processor you run on.
Yeah, and
stuff
some
like that.
runtime error, whatever. But we see a lot of that, and I think integer overflow is also the other half of it.
Okay, so like just being some.
It's like the kind of classic mistakes in a simple problem.
So probably.
So I guess this is the one that, if you're not an experienced team, you will be caught out by this.
Oh, they are manageable. Like you will
ideally people
catch
solve
it
this in the end.
At some point.
I just hope that people are experienced enough to understand that this is the issue in the end.
Wondering about F, I think. Not F, I.
And the other massively solved problem is problem I.
Right, the precision.
Maybe we can talk about this better.
So this is not a problem I worked on hard, or a lot, but I think we should have fixed most of the precision issues here.
Well, I think the precision issue which can happen is when the answer is really small, like 10 in minus 300, which is allowed by...
Which is exactly the maximum or minimum answer you can have
yes,
there,
right? But you would, in most abilities to output and double, you would just receive 0 at that point, which is incorrect. I think that's the biggest trap in this problem.
I think if you just use long doubles...
Yes,
I'm not sure.
The problem, doubles are enough, but the problem if you need to output them precise enough.
Oh, this I'm not exactly aware of, to be honest.
So probably we need...
But that's what
we chose the constraints exactly so
that
it goes to 300.
There should be no problems with double precision, but there can be a lot of problems with output precision.
Okay, this
I'm not sure again, but maybe you can just tell about the problem to those who...
I mean, the problem is basically you're kind of supposed to implement a simple calculator where you're given all these unit conversions, and the question is just convert this to this.
So, okay, let me tell then.
Like a
So,
graph problem, essentially.
so in
Yeah.
fact, you are given some equations like one foot is 12 inches
Yes.
and stuff like that, like converting some strange stuff to some strange stuff. Like
Yes.
the one of examples tell you there's such a time measure as fortnight.
Yes.
Was nice to know about it.
You never know.
No.
This is common British, I guess.
Okay.
Common Turkish stuff, yeah.
Well, and stuff like that. And you need to convert one of them to another of them. So just by finding a path in that graph.
Yeah, so and it's given that the graph is either a tree but not necessarily connected, I think.
Yes, I
So
think
if it's
that's
not
exactly
if
what.
it's in different components, you have to print impossible,
so
and otherwise you
in
find a
fact-
path and you just compute everything along the
So
path.
in fact, it's just basic graph algorithms and some accuracy.
Yes, and I think one of these things you could do in this problem is pre-compute the answer for all possible
I
queries.
mean, I would probably do all pair shortest probably.
But
Yeah, well,
like
that's
another
right.
thing, there's only 100 vertices in the graph and 10,000 queries, so you can
you
just do a
just can-
BFS for every point. And,
Okay.
and yeah.
So, and
so like algorithmically, there's not too much to this.
yeah, so I think
once you
that's my
understand the
programming.
Precision might be an issue.
That's a programming problem.
Yeah.
It happens sometimes on
I
programming
haven't looked much
contests.
at the submissions for this problem, so I'm not aware of any
Okay.
precision issues here.
Maybe we can get
At a
some
later point, we
insight
can
from
look at this.
other juries members later.
Yes.
And I think the other solved problem is problem C.
C. What is problem C again?
Well, that's just been solved recently.
It just gets solved. Yeah. Oh, it's already been solved by 2 teams.
Yeah.
Okay.
So they're
This one is the
getting
moment when we're
faster.
programming and
So do you,
Yes.
can you tell something about this problem?
I think I would refer this to another jury member. To be
Okay.
honest.
we will get other jury members.
So
Yeah,
maybe
So,
just other problems you like.
I mean, a problem I like
what
is
is your
J.
favorite problem?
Okay, so J
I totally
is-
agree with
is-
you.
Is
Yeah, J-
really
We
nice.
already discussed it. That was my
Um,
favorite problems. Oh,
L I also like.
we have a
L is,
team.
geometry. I like it.
Well, we have a team already solved 3 problems.
Uh-huh.
We had submitted on problem H,
H. What is H again?
which is one of the
How's
which
it?
is one of the hard
How's
problems, I think.
No,
Not
it's
the
it's
hard,
it's
not the
hard.
hardest one, but
I would say
It's definitely not hard.
I think it's in the second
H
part.
is just tricky. It's not necessarily hard.
I mean,
I
it's
think
just setting up the whole graph.
G is also a very interesting problem.
Yeah, maybe.
So
So we
did you
discussed
already
this,
discuss the accepted intended solution to J?
I have no idea how.
You have no
To
idea.
J,
I
to
know.
J, or to
Yeah.
J.
I
So
don't know the jury solution. I don't buy it.
sorry, to
And did you
J or
explain
to
it
G?
already?
Not,
J.
not to anyone. No.
The
Ah.
jagged skyline problem.
No, we
Oh,
didn't
that was
discuss
also
it.
the-
So that would be
that
nice
was
if you
the-
tell it.
Okay, but I think it's a bit too early in the contest maybe to spoil the solution. no?
Yeah, don't spoil that.
Um,
Okay.
But we can discuss a little bit about the ideas in this problem. Maybe.
Okay.
Has it been solved yet so far?
I think it's not, but it
Okay.
was attempted a lot.
Right. Yeah. So
Not a lot, but 3
wait,
teams
has
had
it been attempted?
3 teams had
Okay.
attempted it.
So I have seen one attempt that came extremely close to solving it.
Yeah.
The only thing they did wrong is that you have to do a binary search at some point in the solution. I think that's not of much of a giveaway. And there's a height to this grid. And so you can only query points within this height. And if the height is 1,000, you should not start your binary search at 10 to the
Okay.
18. So their solution is completely correct, apart from starting at a too high
Do you
upper
need?
bound.
Is it enough to do a binary search, or you need some kind of binary lifting to get logarithm of actual answer? I'm
You
ju-
don't need that technique here, I think.
Okay.
Like exponential search, what you mean, right? You double from 0.
Yeah,
Yeah,
so
that's,
well, the
what
problem
we
is
do.
that you need to do quite a big amount of binary searches, and I was
Yes.
not sure if just doing a binary search is good
like,
enough.
The completely naive solution here would be to do one binary search per column. I mean, that's not completely naive, but that's kind of
that's
the
okay.
first reasonable approach.
Yeah, but that's not possible.
No, because the number of queries you have is only just more than the number of columns.
Yeah.
Right? So actually, most columns, you can only do one query.
Yeah. This
And
makes sense.
So the
then the
question-
question is, how are you going to manage?
Oh.
Most columns, you have to just discard them right away.
Yeah.
I'm not going to say much more than this for now. I
Okay,
think I'll
that's-
let everybody
I
think for
guess
a
we
bit.
know
Let's
that.
everybody
Yeah.
think about that. We'll already get some
Um,
spoilers probably, but
Yeah, I think one other remark I have is regarding problem L. There's a lot of time limit exceeded submissions on this so far.
and are there something
the
smart or
alternate-
just quadratic solution?
So I've seen a lot of quadratic submissions
Yeah,
here.
they're not as good.
And it's just kind of unfortunate that apparently some contestants don't seem to be aware that 10 to the fifth square
10 to the 5 is hard.
is going to be a lot.
Also, well, I have a question to the problem about the problem L. The statement said that each run will run on new set of random
That is
tests.
true.
I have two questions, like why and how.
How we implement this as an interactive problem,
Okay.
where the validator, we have some issues in this in our backend actually. The validator just generates some inputs.
But why?
Okay, so the first question is why, yes. Like we say random inputs, and if we say random input, we mean it. And so we're going to re-randomize every single time, because then it's truly random.
Because otherwise it might be that a certain implementation just fails.
Yes.
Because it's the wrong
Like
one.
we cannot, if we make random data with a fixed seed, we
Okay.
cannot exclude that some implementation just doesn't work on one of our cases. That would be very unfortunate.
Yeah.
Okay.
So
that
right now
makes
what's
sense.
happening is, there might be some solutions that are kind of tricky and that pass the entire test set with some constant probability around the half. Can happen. But then that's just a risk for the contestant to take. Like you could analyze it further and
Well, probably in that cases you can add some your own randomization at some point, but okay, that makes sense.
yes. So and the way how we do it is we just implement it as an interactive problem. It was actually interesting because some test submissions, they read until the end of the file, but in interactive mode, there is no end of file. So this week we implemented that our interactor it closes the output stream.
Yeah,
so
okay.
that teams can do it.
I think that's also there an issue, which is no probably the case in this problem, is like some people like to output something before they read the whole input. It's probably not the case of this problem, but this can lead to buffering issues too.
Yes, this has happened in the past, and it's all very tricky.
Okay.
Yes. I think in this problem, it's not an issue. In
Yes.
general, in this kind of problems, yes.
But I've
once
never
there are
seen such a
problems, the only thing we can do is advise teams to read all the input before printing an answer.
I understand, but that's I
These
think
are
the
just-
first time for me seeing that approach to deal with this
we've
fixed
had
set
this kind
problem.
of problem with guaranteed random input for the past 2 BFCs, I think.
Yeah.
It's kind of become a theme now, and every single time, it's also kind of taxing on the hardware, because we guarantee 100 test cases, and they're all kind of large.
We have a solution for... Meanwhile,
Yes.
we have a team solving problem H.
Aha.
It's
That's
a
very
Delft team. Maybe you can tell us something about this problem?
Okay, I think this is going to be the last one.
Okay.
More things to do. Some other jury members can take over at some point.
I hope we'll have more jury members later.
So what did you already discuss about this problem?
I think almost nothing.
Almost nothing. Okay, so the problem is that you're given a graph with n vertices and edges. So this means the graph is almost a tree. It has one cycle because it's also connected. So normally you could have different components, each with one cycle, but in this case, it's one component with one cycle and the rest
Very
is...
important observation for this one.
This is super critical, yes. I think at some point we didn't guarantee this and the problem was much more messy, and then we made it a bit simpler with this guarantee.
Yeah.
And then the next question is, we have all these trees.
Microphone.
Oh, a bit closer? Okay. We have all these streets where one end of the street has house numbering 1, and the other end of the street has some upper bound. It's in the input, I think. What's the number given here? H. And so you have to order all these streets in the right direction, so that at no intersection we have twice the same number.
That
So you
makes
cannot have
sense.
2 outgoing edges at the same node. in that sense.
Exactly. Yeah,
Not
because
only.
outgoing edges always start at 1.
That's not the only.
No, it's not the only,
It's
but
not-
it's definitely a
This
minimum
is
requirement.
at least a very strong initial restriction.
And that only gives you very few options, I guess.
Yes, so can you think a bit about this? Because like you can ask, how many ones do we have to put in this graph? Like how many outgoing edges do we have? N. And how many vertices do we have? Also N.
Yes.
So every vertex needs to have one outgoing edge. So everything with degree 1 is already fixed. It has to be an outgoing edge.
Or every subtree is fixed.
Exactly. Let's draw. Can we?
I think we can do this, or
this how
there
to
is an eraser.
That's like this. So if we have some kind of graph, and then since we just deduced that this graph is only one cycle, it will look something like this. Something like this. So like we discussed, everything with degree 1 has to be an outgoing edge, where we mean that outgoing means that here is 1 and here's h of this edge, whatever it is. And then this has to go like this, and this, and this. So what is now the next step we can do?
Yeah, there's 2 options for the cycle.
Right. There's exactly 2 options for the cycle. I first wanted to say that this edge.
Well, this is a point into the cycle, right?
Exactly. I'm thinking of like the simplest argument to say why. But if this points out, then in this part we have one more. Like we decided that every vertex needs to have an outgoing edge. So this vertex needs to have an outgoing edge, and it's not this one and this one, so it must be this one. So all these trees hanging off the main cycle have to point towards the cycle.
Yeah.
And now we have a cycle, and everything has one outgoing edge, so there's 2 options. Let's see if we can use color again. So we can either point them all to the left, or all to the
Unfortunately,
right.
it's not really visible on stream.
The colors.
Neither the colors nor arrows themselves.
Oh, that's unfortunate.
Well,
Well, what can I do?
Yeah, move it all the way down.
Okay.
there we go.
And this one a little bit up.
It's a bit better now.
So anyway, we can decide that or conclude that there are only 2 options for this cycle. So in the entire problem, really, there's only 2 cases we have to test. We first orient all these tree edges at the outside the tree, and then we try both options for the tree. And this trying both options, we have to like especially take into account the other ends, because it can be that this is going to have a 3 for the length of the edge, like for the house number, and then maybe this edge has a 3 as upper limit, so it has to point this way, so that there's a 1 here and a 3 there, because 2 3s on this node would be a conflict.
Yeah.
So it's a bit tricky to implement this nicely, but in the end, it's relatively straightforward, algorithmically speaking.
I agree.
Yes.
Very nice, thank you.
It
Okay,
requires
you're welcome.
you to understand it. Thank you a lot.
I'd be happy to come back later to talk about more of the different
Okay, or
problems.
maybe
We'll see.
some
Yeah,
other jury
we'll
member
discuss
who
it,
can
it's
talk
fine.
about
Yeah.
the problems you don't want to talk to.
Yeah, exactly.
Saint-Renier. Yes, many problems, right?
Yeah, I'll see if I can make him come. Thank you.
So Peter, when am I being replaced? Is this ever happening? Or is this my day job now?
About 10 minutes.
I'm quite happy with talking with you, but maybe we have some sponsors at some point.
Yeah,
For example,
I think you should have some
should
sponsors.
have them.
I mean, I came here, just for a quiet day, not to actually do something. But, this is fun.
So, well, can you please show a scoreboard now
Scoreboard, please.
to check what's going on? Oh, teams from the 3rd place had a submission.
I mean,
And it's
Oh,
correct, and it's
oh.
our first team with 4 problems.
oh, Delft.
And it's
Goddamn
Delft University. They solved all 4 easy problems, I think. So the probably they understand that the next one should be problem C. That is already solved.
Mhm.
And we're waiting for what will happen next. I think we could have a lot of teams with 4 soon.
Yeah, and then the
And-
real game starts, I think.
And then it helps the Delft University to come up with better time. Because now, well, if you solve the problem right now, you'll receive 90 minutes. So in fact, the second team has around 20 minutes to solve the next problem to be not overcome with Delft.
Yeah,
So, and we got a second
Oh.
team with 4 right now.
there you go. Radboud.
Radboud University, which is now having 4, the same 4, I think. So they solved.
Have you replaced by
problem.
Mark? Exciting.
So thank you a lot. That
Yeah,
was
you're
a bit
welcome.
long. That was a bit longer than you expected, but that happens
Doesn't matter.
sometimes.
It happens sometimes. I mean, you're going to have Mark now, so you can talk a lot. This is,
Okay, so that's nice. Now we have now 2 teams with 4 problems, a bunch of teams with 3 problems, and a lot of problems too. And I think most of teams have already solved at least 1 problem, which is very nice. We have only 10 teams which didn't solve any problem. So nice to meet you. Can you please introduce yourself?
Thank you. Yes, of course, I can. I'm Mark van Helvoort, and I am one of the so-called proofreaders, which means that I had to take a look at the problems before the problems actually were published. So I had a chance to just think about them and solve them in pretty much my own time.
it's really nice work. As a jury member of a lot of contests, I can say that it's really. Oh, we have one more team with 4, so they're coming really fast.
Yeah, it's good that they finally start to get out steam.
Yeah.
Because the start was relatively slow, I think.
Well, that happens sometimes. So, and I can say that help of a fresh view of the problem set is always can be underestimated.
Basically, it's too late because usually the people that are producing the problems, they have their own mindset,
yes.
which they so it's not immediately clear for everyone what they always mean. So it has a function of also clarify the problem, basically.
Yes.
And then there's the other end that you get to solve them in your own way. And sometimes it's not the way that was anticipated or expected. So it also gives some new views.
I can say that for me personally, not sure, maybe your jury is much better than this. There are people who know English much better than me.
Yes, but I don't think I'm one of those, to be honest. But
that's really other helpful thing which can be
that's
done.
true. Yeah. So also some grammar checks occasionally, yes.
Well, not just grammar checks, they can be done automatically good enough, but like stuff like you don't speak like this in English.
No, that's true. That's true.
Yeah. Which is often useful to use a fresh view. So, which problems do you like most?
Oh, there are some problems that I really found original and are really nice. For example, the problem L with the
problem L.
Which
it's
is
a geometry problem. We already talked about it a bit.
Yes, so this is one of the problems I liked, especially because there is different ways to solve them, and a lot of them include some random factors that are not regular for most problems. So.
I think you like random stuff here. Like there are some randomness involved in problem J, some randomness involved here.
To be honest, in J I didn't like it so much because it basically messed me up. That's the part of the problem that I had struggled the most with, and I think most teams will struggle the most with this.
Okay, but I already told this. That's like mind blowing in sense like when you read problem, you just say how
exactly.
it can be even possible.
It is a very diffuse set, so to say. So there's many different types of problems being handled, and also
it's always nice.
Yes, and I'm actually a big fan of the interactive problems. That we also found one in the preliminaries, and I really enjoyed that one.
So are you participating in preparing preliminaries?
No, I also did the proofreading for the preliminaries and the current contest simultaneously.
Okay.
So all the problems were basically in a set all together, and I spent the vacation to actually solve a lot of those.
We have several people who are specializing on proofreading, and that's always really useful. I think we have one more people. Okay. So maybe so you have interactive problems, you have problem L.
Yes, and I also have a very I have the tendency to solve problems in a way that they are not they shouldn't be solvable that way. So I like to do things that are that should be structured in a very
like a pen tester for trying to wrap around.
Yes, so
test.
I try to do things like do things greedy when it's not supposed to be greedy.
Okay. That's often quite. I think the most hard part of jury work is come up with wrong solutions, especially when you know the correct solution.
Yes, and we all, to be honest, we also had some problems in which we produced a solution that should have been wrong, but then it wasn't tested. So they actually included some tests based on the work that we did.
That's always really important part of work, and having special people specialized on it. I think we have one more team with 4 problems.
Very nice.
So, what is your expectation? How much will the top team solve?
To be honest, there are some of these problems are very challenging. I also didn't solve all the problems, so I think, there is now a set of 12 problems. I would expect the top teams to score around a 9, I think.
Around 9.
Yes.
So that's quite different what we heard before. Like previous speaker said that he expects 11.
Yeah.
So he
yes.
expects everything except problem G to be solved. Problem about grinding gravel. I think we both think that's the hardest one.
To be honest, I don't necessarily agree. I'm not the ultimate expert on this, but I've also found problems A and K to be quite challenging.
Well, problem A.
I think A is mostly challenging because it's more of a mathematical problem in.
Problem A.
Yes.
Okay, why not?
So
Sure.
I think A is going to be the surprise of the set in terms of
Maybe.
solvability.
That's happens sometimes. I'm not sure if. Okay, we'll see. I don't know. I think it's kind of standard approach. Like I think that okay, you see there's averages. If you've seen this problem with averages, you know that you need to subtract and etc. I mean that it's like it's not trivial, but
The thing is that this is one of the problems that look very easy, but it's very easy to lose a lot of time in it.
yes, that's true. So it's definitely at least you definitely can. It looks to be quite within time limit. I think it has like 1,500 and something like n squared log n, maybe multiplied by 4, maybe multiplied by 16 solution.
Yes.
And this can be quite hard to squeeze it in time. Oh, we have team with 4 problems submitting L, and they are almost, and it was almost correct. As you see, their team was how many tests they have passed is shown as yellow progress bar.
Okay.
And it was almost full.
Yes. Well.
So team passed at least. I think
This is
60 tests maybe.
But L is one of the problems where it could actually go wrong by a small chance.
Yes,
if you are like unlucky, you could resubmit and it could work.
Probably just resubmitting is not the best strategy.
Well, in this case, it could actually work.
Well, you could get quite a bad penalty if you try to do that, I think. So it's like last minute option. But I think that just optimizing something slightly could help them.
Yes, actually what we have produced, because I worked with Nikki on the problem sets during our vacation. And we actually gave a solution for L. It worked. And then we started to shift the parameters to see if we could do it like with less time, with less optimization steps. And we came quite a lot, quite far with that, and it was still accepted. But there is, of course, a larger chance that it will accidentally fail on one.
Okay. So probably they will need to. We don't know how far they are, but well, we don't know how far they are from solving. But we see a lot of balloons here. So do we see some new colors? I'm not sure. So I think one of the team with 4 is just in front of us, which is balloons are really nice for stream because we can. I don't know not anything about the teams, but we can see that it's one of the top teams.
They're always mixed, so it's also nice.
It's just beautiful.
Exactly.
Anyway, well, it always was really nice, like going with them. I think.
But you also participated for a couple of years, or?
I'm world champion in 2014.
Oof.
So yes, I participated for a couple of years.
Okay, so I'm basically talking to a genius. That's always nice to know. I never got that far.
That's okay. Oh, we have problem L solved by Delft University. I think that's the same team which attempted some time ago, and it's the first team with 5.
Yes, but it's they attempted it like a few minutes ago, so probably they missed like one optimization step that they now done.
Just optimized something a bit, and that was enough. As we say, that they already passed like 60 tests from 100, so they was not far enough. Sure. And well, that can be misleading for other teams. because problem L is tricky. You can spend a lot of time on it.
Yes, it's tricky, but there are also quite a few ways to actually do it. If you know in which direction to look, it shouldn't be extremely difficult, I think.
Okay, that's nice. So, well, I have the difference between their code, and to be honest, I don't understand it.
That's always the best improvement.
They just try to do something twice instead of once.
Yeah,
I don't
that sounds
understand.
that sounds like an optimization step. Yes.
I don't have no idea what are they doing.
Well, I can shortly explain you how I came to my solution.
Okay, that would be very
And
nice.
I can actually explain what we did in the optimization steps. So what you basically get is a lot of random 3D points. So to
Yeah.
speak.
So in fact, basically, the problem is just you get a
you get too
bunch,
many.
bunch of 3D points and need to find two closest one.
Yes, and you get too many to brute force it.
Okay.
So what I proposed and what we did was we took 100 random points within the space, and we assigned every point of the data set to the random point chosen that is nearest to it.
Okay.
And
So it's some kind of clustering.
yes, so you get and the points that we chose were completely random. But so basically what you do is you get a set of 10,000 points, you divide them in 100 clusters. Most of them will be around size 100 to 200 max.
Probably they should be. If they're
Yes,
random.
and those clusters can be brute forced. And the optimization steps, and it's very likely that the closest points that are closest together are within one cluster.
But they can be in neighboring classes.
Yes. So what we did then in the optimization steps is that we took the midpoint of the clusters as the new random points, and then try to rearrange the clusters, so to speak.
Okay.
And if you do that a couple of times, then you get actually you're pretty sure that the clusters with the nearest points are clustered together.
Okay, that's really nice. I think the other possible approach is something like you can have some grid, 3D
Yes.
grid, and you need to be check some only neighboring buckets. There can be approaches like that.
I have seen some different approaches by the jury. I think I was pretty much the only one that did it with random points.
I think it's possible to solve it without randomization, but it's quite hard with divide and conquer like approach. As I know, it's quite easy to make it n-log squared, and kind of there are some stuff I don't know how to make it n-log n.
Yes, well, they did they really did some magic that I also don't understand until this
Okay.
day. Like I said, I'm
and
not an
we have
expert.
problem D solved, and another team with 5.
Very nice, very nice.
And our leader from Delft has still not solved problem F. Can we please check a scoreboard? Oh, our leader still
Okay.
not solved problem F. So then they will soon have 6 problems.
And they also didn't
probably.
solve problem B yet, did they?
No, I think they did solve problem B now. I think they got B, E, and H,
I
I,
thought
and L.
I thought I saw that they also didn't solve B.
I think they did that. Oh, they didn't
Oh,
solve
see.
B, they solved C. They just love random problems.
Yeah,
Okay.
they love the problems that nobody else loves.
Okay,
That's,
so they
that's
have
also-
just 2 problems unsolved now, 2 easy problems unsolved now. That should be hard to overcome them then,
but,
because they can have 7 quite soon.
but I would like to point out that by now I think 8 problems are actually solved at least once, 7 or 8.
We can check it on our statistic dashboard.
It seems to be 8, I think. B2,
So we
F,
can
and
check
I
it
and
here.
L.
Yes, I think A, G, and no, 4 unsolved. Yes,
Yes.
A, G, K, J, and K.
And I would like to point out that A is still not solved.
Yes,
It's good. That problem
That's
is very
not-
tricky.
it's not. I don't think it's so tricky, but it just requires a lot of work.
Yes, exactly.
Okay, well, it's nice. It's an obvious problem for me. So top team has an interesting strategy.
Ooh, someone's trying K actually.
Yes, so it's another Delft team which has 3 problems now, and I think they succeeded.
Yep.
Yes,
Oh, very nice.
and that took them to the 5th place with 4 problems, and we have 1 more problem solved.
Very nice.
And so they will get some new color of you have a lot of dark blue colors. I don't really distinguish them. But they gave some dark balloon.
Yes.
Okay.
Very nice. Because I also found problem K to be one of the toughest, actually.
Problem K, to be honest, I don't remember what is about it. Oh, I got it. That's a nice problem. I think that it's beautiful in the sense that you need to check many approaches. Like there are a lot of approaches when you can start and end to nowhere.
Yes. Yes.
So that's need to you think in a kind of different way, not like depth search, but by checking
Exactly. Yeah.
different approaches. And also like this idea of getting from the end.
Yes, I think it's quite tricky to come up with a
Yes,
solution
but
there.
on the other side, it should be quite easy to implement when you come up with it,
That is true. Yes.
which is always nice. Okay, so at current point we have a bit less than 2 hours past. 140. So well, we have a lot of teams have a lot of time to work on different problems soon, but I think current leader have good chances to. Fix it.
Yes. What surprises me is that there are so many different problems that are actually solved, but there is still no.
Oh,
I
one
think
more,
there is-
one more solution on K, I think.
Yes. Very nice. But there's still no team that is beyond 5 solved, is there?
No, we have 2 teams, I think, for solving 5, as shown
Yes,
now.
that solved
We-
5,
we-
but not more than 5.
No, yes,
Which
that
is
happens.
after 2 hours. It's
Well, that means that something went wrong for some teams, or just it requires some implementation. But they are becoming faster, definitely.
yes.
As at least Delft team, which now done with hard problems, can return back to easy ones.
Yeah, that is actually true. But I also think that this will become a self-fulfilling prophecy regarding A, because if it's not solved now, will be many teams that will be hesitant to start at it.
Yes, that's true. Well, I remember some contests which worked like, okay, there are 3 easy problems which are solved, then nothing happens, then like in
Yes.
15 minutes 9 more problems solved by one team each,
Yes,
and the
yes,
only remaining problem had no chances at that point.
yes, I can imagine. Yes,
I think that was
I see suddenly a lot of people trying K.
well, so we can check how many teams already tried it. I'm not really sure. Can we check it? Yeah, so we have only 3 teams tried and 2 of them succeeded. So I think the most teams has problems with F. So otherwise, for other problems, they are just mostly come up with.
Yes, but F actually has some tricky edge cases. I think.
To be honest, I don't understand which ones, but
I think there is some
why you need to write solution.
yes, there's some trickery going on with the directions in the 45-degree angle, so to speak.
Oh, okay. That can be tricky.
Yeah, there's something with the string length that is going to be different there than it is for most other cases.
Okay.
If I remember it right,
Makes
it's been a while.
Well, it requires some casework. That's true. So the problem J, I don't remember what's it. So teams are solving different problems. That's really nice. That I don't think that any problem which is too hard.
Too hard? No, I wouldn't.
So
say
all
it was.
problems seems to be possible.
But I found it interesting that you found G the hardest problem of the set.
Well, I mean it's hardest in the sense that I have no idea how to check if my solution works without implementing it. It's the problem which requires a lot of computer time. You need to implement some solution and experiment with it.
Yes.
I have no ideas if it would work. While with other problems, when I come up with a solution, I'm quite confident with it.
Well, G is the perfect example of a problem that we try to do in a different way than was expected. So we actually tried a greedy approach, and it
Shouldn't work.
there is a few edge cases in which it doesn't work, and you can catch them. So it is possible to do it greedy, I think.
Okay, maybe.
That's basically because the boundaries are quite
Okay,
low. So to
maybe.
say.
So we have our next guests probably.
Very good.
Now, so thank you a lot.
And I will hand them over.
Maybe you can say something more. And I will wish luck to the
Yes,
some
I wish all
teams.
teams, of course, very much luck. I don't think every team needs luck, but the teams that actually need luck, I wish them a lot of luck, and I hope they manage to enjoy themselves, because that's the most important thing, I think.
Always. Thank you a lot.
Thank you.
And we have our next guest. That was not intended. Can you please introduce yourself?
Yeah, hello. I'm Nadine, and I'm the NWERK director for the NWERK in Delft this year. And it's on the 25th till 27th of November. And I'm organizing this with the Gypsy committee, and we're very excited to organize this. Yeah.
So that is the contest which teams are selecting from here.
Yeah, exactly.
So they are participating for ability to participate in your contest, which is nice. So maybe you know something about teams we didn't know yet, which you expect to be winners, which you know nothing.
Well, we're going to see who is going to perform really well.
So you are working on Delft University.
Yeah,
and your teams are performing very well right now. I can temporarily congratulate. Let's hope it will stay.
Yeah, we have a few teams indeed that are performing really well at the moment. And
do you have any ideas why your top team not solving simple problems? They just have a really strange set of problems right now.
Yeah, I think you have to ask after the contest what their exact strategy was.
They definitely have some.
Yeah.
And it looks like it will work well.
Yeah, I hope so, yeah.
Okay.
So, yeah, basically why I'm also here is that for NWERK we still need some volunteers. So we're, of course, very excited to still see the teams that perform really well here at NWERK itself. But for teams that are performing a little bit less and maybe don't qualify for NWERK, we hope that they are willing to be volunteers at our contest. And they can go to the link wisv.ch/runner.
Can you please add this link to the stream? There is a line. Okay, so the link which appears in stream in some point soon.
Yes, nice.
So what you can do with this link?
Yeah, so you can sign up your availability for the weekend. So from the 25th till 27th, when you will be able to help us.
Can you please get this paper to Peter?
Should I? Yeah, you got it?
Okay.
All right, nice. And the task that they can help us with is with being runners, so bringing all the balloons to the teams, what we also see happening today, and also help with setting up the whole contest. We, of course, need a lot of people to make it go very smoothly. We're looking for enthusiastic people that can help us with this. And of course, we will also provide food during the day and some gadgets for our volunteers too, so they also will have something nice that they can take home with them, next to having, of course, an amazing experience at NWERK.
To be honest, I participated as volunteer in some contests. For example, there was a couple of contests where I just was balloon runner, and it's really fun.
Yeah, it is.
Always.
We also host the ICPC, the preliminary in Delft. And with that, I also always help with bringing the balloons. And it's just so much fun, all the different colors and like the excitement that you can see on the team's faces when they get like a new balloon. And then, of course, during the contest, you see more and more balloons appear. And it's just a very happy sight.
Oh, we have the problem. So the Delft team is come up with 6 problems. They decided to start solve simple problems. And now they have 6, and probably they will have 7 soon.
Yes. I'm very excited.
Do we have any other teams with 6 right now, or at least attempted 6? No. Maybe we can check. So we can check it on scoreboard. As we see that Delft team has now 3 first to solve problems.
Yes.
Which is still nice, and probably team on the second place, which have in D, can have some good chances too, because it has a lot of problems which are shown to be solvable. It could become interesting.
Yeah.
I probably think we can see like that.
Yeah, I think it's always very interesting to see how it works with the scores. Like teams that are performing very well in the beginning can always end up very far in the list at the end. It's always very surprising to me how those dynamics work during the contest.
Well, sometimes something goes wrong at some point.
Yeah, unfortunately for the teams themselves.
Well, but there are also some comebacks.
Yeah,
Like,
definitely.
For example, I think while I was a participant, our coach said that almost every year there is a team in medals who solve at least 3 problems on the last hour.
Yeah, yeah.
So
But that's why the score freeze is so exciting, because like as soon as the score freezes, it just keeps being like very exciting to see which team will end up higher.
oh, and we have one more first to solve by I don't remember the university name. Unfortunately, maybe you can help me.
It's the VU. It's like
Okay.
yeah, the university from Amsterdam, the Vrije
Okay.
Universiteit.
The Vrije Universiteit, which solves the problem J, which we discussed to be a non-trivial one, which someone thinks it can be one of the hardest ones. And now the only 2 problems are unsolved.
Which one?
The problem A, which have 3 wrong submissions, and the problem G, which has even no submissions.
Yeah.
And for all other problems, at least one team solved them, which means it's a good problem set. That
Yeah.
team can choose what do they like.
Exactly. That's really nice.
Okay, so what is why you organizing work? Why I mean not as organizers but a team as a whole, but you personally.
Personally, so I've been involved with ICPC contests for a little bit longer than 3 years now. And the first time that I was involved with it was via my committee at Delft, the CHIPC that organized the program contest, and I became a member of that committee. And that's how I got involved. And the first time that I saw how the contest works, I found it like really exciting. And I think it's always fun to organize these kinds of contests because it's fun for me to be able to organize these contests, but it's also fun to see how the teams are excited to compete in these contests and what kind of benefits this brings to teams, like joy, but also opportunities for like in the future, like experience, but also for job opportunities, traineeships, etc. And I think it's really nice to be able to also help organizing these contests to give these opportunities to the teams that are competing in it.
That's really nice to hear. Like I really like ICPC communities in different places. That's a lot of people would at least just like what they do.
Yeah.
And that's
Yeah, I think that's really defining for the whole community, that it are all very passionate people who are really happy to work to make the best contest possible. But also you see that a lot of the people that first competed in the contest later get involved with the organization. And I think it's just a really nice community to be in and to see all the excitement.
I totally agree with you. Oh, and they had 7. Meanwhile, so now we have 7-5.
Wow. Yeah.
Yes, we have leading by 2 problems, and even 3 problems from the third place, which can help them to solve their penalty time issues, actually, because they didn't have a really fast start.
Yeah.
But then it went much better.
But I think that's always part of their strategy to first
So
really.
do you know something about the team?
Yeah,
They're always doing like that.
Well, I can't say that they're always doing it, but we have seen it in the last couple of contests that they.
Is it the part of the strategy to mislead other teams?
Oh, I don't know about that. You should ask them if that's their strategy. I know that they are very thoughtful about how they approach it, and I think you should ask them for the specifics, like the
Try.
why.
Oh, and we have submission on problem G. Meanwhile, it's this team from Louvain. Sorry, it's hard for me.
You see Louvain, I
It's
think.
Louvain.
Yeah.
Okay, I'll learn this at some point.
Yeah.
Tried to solve problem G as their third problem.
Yeah. It's always
Got wrong answer.
always with the team names. It's hard to pronounce them. I always do the resolver at the preliminaries, and then I also have to pronounce the team names.
Yeah, and then in resolver you need to do it really fast.
Yeah, so
Which is
I
even
always
harder.
yeah
And just talk without stopping for an hour.
I always say sorry at the start of the award ceremony, because I'm like, I can't guarantee that I pronounce the names well, but it makes for a really funny award show most of the time, because I'm just standing there doing my best to pronounce the names, and yeah, everyone finds it, I think, quite funny. But I do know with like Sekvald Kobre that they are very excited and always very happy to compete in these contests. I've seen them now multiple times, of course, and they're really nice guys and doing their best to really, get a good place in the contest.
Well, jury says us that submissions on problem G is not really close, even close. So probably it's just some greedy heuristics, which is wrong. That's quite unfortunate for the team, but
Yeah,
that happens.
yeah.
That's probably the hardest problem of problem set. So
But then it's also logical that it
yes.
takes some effort to solve it.
But well, hope. Oh, I have some problems with power. Okay, I'll check it later. Sorry for that. Okay. So, what would you tell more about Werk? It happens in Delft.
Yes, it's a 3-day event, with the first day being a registration day, of course. On Saturday, we have the test session and also an afternoon filled with fun activities. We really wanted to make sure that teams get the opportunity to get to know Delft, but we're also going to give the option this year that they can get to know Rotterdam, because it's really near Delft. So we really wanted to give that opportunity that the teams could see a little bit more of the Netherlands. And then on Sunday, we of course have the main event, and that's the contest. And really excited how that is going to go. So yes.
Okay, I hope I would be able to attend to it
Yeah.
too.
Yeah.
And so and this is the last stage is selection for World Finals.
Yes. Yes.
And so it's selection for World Finals for next year, probably, or.
I'm not sure how it works because we had, of course, COVID and like.
Yeah, so COVID messed up a
Yeah.
lot.
Yeah. So I'm not sure. Like, I think the World Finals of next year is going to be a 2-in-1 contest. But so
That's some I know that there are some strange rules in eligibility. Maybe you should
Yeah.
know better than me about them.
yeah.
Because
Well, for those kind of things, you can always contact ICPC themselves for asking about eligibility rules.
so they're really hard now because of this COVID stuff.
Yeah, yeah. But I'm looking forward to see you at NWork. And thank you so much for having me here.
Okay.
Yeah.
I hope we'll try to do something. Maybe we'll try to help with stream again.
Yes, that
So
would be nice. We're
let's
definitely
see.
looking into the possibility to be able to broadcast the contest. So yes. All right. Thank you.
Okay, thank you a lot. And we're back now. So thanks a lot for our sponsors, ProDrive. And now we have one more jury member in our room. Can you please introduce yourself?
Hello, I'm Ludo. I'm in the jury. I also added some problems.
So we will be able to discuss some more problems with him. And now we can check what's happened for these 15 minutes. We was not discussing it. So can you please enable a scoreboard for us? And now we still have one team with 7, which solved the easy problem, not on the hard ones. And we have a bunch of teams with 5. I failed to get how many, but there was around 5 or 6 teams. And a lot of teams with 4. And I think almost all teams are done with their at least one problem. So we have 5 teams with 5 and attempting on different problems. So not too much changed, but okay. So what problems did you prepare?
I prepared exercise A here, adjusted average. I can explain it on the board.
It's one of 2 unsolved problems at the moment. I think
It's still
only problem A and problem G is unsolved. So this is a hard one.
Yeah.
We can try. So can you please explain the problem and solution?
Yeah, so the problem is about some data points are given, and there is this average of the data points, but you want to adjust this average to some target value that is close to x bar. And the way you want to do this, so you have a lot of numbers, but you can only remove at most 4 numbers from this list. So the naive approach would be to iterate over all these ways to select at most 4 elements from this list and just check if this average is the closest to the target. But this complexity would be n to the 4 divided by, So that doesn't work. And how you can solve this is by doing meet in the middle. So what you do, so you want to find 4 indices of which you remove these. So for example, 2 indices I and j and 2 other indices u and v. And thing is, you iterate u from left to right, and in doing that, you can remember right. So the first step is this x bar is an integer, and you can subtract this from each element, and nothing changes. So you can assume that this one is 0, for example. And then what you need to calculate is the sum of these elements. And basically, if you fix the number of elements you want to remove, you want this sum to be as close to 0 as possible, because then it's closest to this new average. So what you can do for these I and j is for all these I smaller than j, smaller than u, you can make a set of their sum over all these I and j. And then once you fix this u, you can iterate over v. Suppose you remove these 2, then the best options for I and j you can remove are those with the sum closest to minus this sum. Because then if you add these, it's closest to 0. So in that way, iterating over u and v is O(n) squared. And these I and j's, you can put these in a data structure like a set. And in total, this complexity will be, so there will be n squared pairs at most, and you get a log factor of finding an element in there. And yeah, this can be with like a...
That's a really nice way of getting work around with a possibility of look up in removing an element several times, because okay, this intermediate idea is quite asking for here. You just want to do it, but the way I thought about it was like just have an array of all pairs and trying to get two pairs and somehow deny to get intersecting pairs.
Yes.
Which is kind of tricky, and your solution is much clearer at that point.
Yeah. Yeah, you have to remove some, like, yeah.
That's quite an...
There's still some way to correct for these same indices.
Yeah, so, but I think that its problem is anyway quite tight in time limit sense. It has 8 seconds time limit.
Yes.
And
So it's yeah. So this high time limit is mostly for Python solutions. These
so
still can be.
So it still can be solved on Python.
Yeah.
Well, it makes sense for this problem because probably any worse solution is too bad.
Yes.
So it's really nice if it's possible to solve it in Python. I'm surprised. So maybe you can just... Do you have time to just have some talk about... Some general talk. So, was this the only problem you're working on, or maybe some others we already talked about?
Yeah. So yeah, I came up with this problem A, and yeah, that's the only one.
Okay, so that's already quite a big. For example.
So I also made some solutions for the others.
Especially when you regularly participate in preparing problems, it becomes very hard to come up with new problems each time. So even creating one problem is a big achievement.
Yeah, it's different than solving them.
Yes. So, and which problems do you like more? And so, what's the problems you like most in the problem set?
Well, yeah. So problem G is quite nice.
Do you mean grinding gravel or
grinding gravel?
It's quite hard to me to distinguish between G and J. It's we had 8 problems solved. So team from Delft solved 8th problem, and now it's 8555, which is even bigger lead.
Yeah, it's a huge lead. So interesting about this segfault is that they didn't start with E or
they
B.
Have a very strange problem order. Maybe they have some strategy, I don't know, to mislead other teams or something like that. Well, okay, and so not only about problems. What is your ICPC experience? Did you participate before? How you come to this point when you're preparing problems for PUBG?
Yes, so first time I participated in this BEPC was in 2015. And I just kept participating every year until maybe 2 years ago. And yeah, I liked it a lot and went to the Amberg. And yeah.
So you are now already graduated, or?
Yeah.
Okay. And
that was 1 year ago.
And what is preparing problems for you? Why do I do that?
It's in some way nice to also keep involved in these programming contests. It's a nice group of people together, and I like to be involved in that.
So
still,
thank you a lot. Maybe you can, I don't know, some final wishes for teams, or I don't know, just some final thoughts until we come up with the next guest.
Yeah.
So
so I guess
you wish.
If nothing weird happens, then this segfault
probably they should win. Then 8 versus 5 is a big, but it happens sometimes. Like teams not solving any teams on next places have quite a lot of time to solve next problems. So
Yeah.
anything can happen.
All right.
Okay. Thank you a lot. And we have our next guest. So can you please introduce yourself?
Well, hello again. I came back. Mark van Helvoort. I'm one of the proofreaders of the set.
And also you can tell us about the backstage.
I can also tell you a little bit about how things are going backstage.
That's always interesting part because because there are really a lot of work to prepare in the contests, which are totally invisible, and it's by design. That if you see it, that something went wrong.
Yes, that's usually true. Like always, there's a lot that can go wrong. To be honest, this session so far has been really easy in terms of setup. We had very little difficulties. I also was involved in earlier years, and we also had a lot of stress on the last day and the last evening, and also the day itself.
Well,
I think this year it went very, very smoothly. Only a few minor things that needed to be solved on the last minute.
that's called experience.
Yes, it comes with experience, but also I think we came more and more prepared, and I think that's actually
It's also nice, and maybe it's just you had more time to get it because I understand correctly that the place where contestants are writing is just university lecture places. So
yes.
they can't be freed in advance because university need to put their lectures
Exactly.
somewhere.
So you can only start on the Friday evening basically, and then a lot of things need to happen because you need to
Yes,
put all the laptops in place, the networks, the power, everything needs to be done with all the technical difficulties coming with it.
So maybe what is most
Well,
interesting,
I think one of the things that usually gives people the most problems is the printing, because it's
always awful.
that's always it's always troublesome. This year was no exception. So that was actually the thing that took the most work in between the test session and the regular session that's happening now. But still, all added together, this year went very, very smoothly.
It's really nice. That means, and well, maybe that's, I don't know, experience of preparing work here a couple of years ago.
Yes, and there is a lot of people involved that have been helping and assisting these contests for years. So these guys know what they are doing from A to Z. So that really helps.
Always important to know, like when someone has plan, it's always easier.
Yes, exactly. Yes. So yeah, I think everyone is so far. Let's hope nothing strange will happen in the coming hours.
Yeah, we have.
But I think so.
2.5. We're only in the middle.
Yes. So
Oh, we have one more team solving first problem, which is
very
nice. Congratulations to them.
Very nice. Oh, this is actually a good story because this is the team from Twente. They had 5 teams planned to come here, but only one actually did show up. I don't know if we actually know what happened to the other 4.
I hope nothing bad should happen.
But at least now there is a way to distinguish the team that was actually here from all the other teams, because now they finally solved their first
that's
problem.
Nice. I hope nothing bad happened. They just have some transportation issues.
I don't know.
Or something like that. Okay. So for now we have probably 43 teams, or maybe even more, who solved at least one problem.
Yes, I think this was
a good result.
Yes. So I think almost every team has solved E by now.
Well, we see that 3 teams who submitted E didn't solve it yet. And maybe some team didn't submit it. Probably this we can just adjust the bar. I think that was for 5 teams who just did not submit anything.
True. I think some
maybe they just did not appear to the contest.
Some teams actually didn't show up.
And we have one more team with 5, one more team with 3. So it's always nice to see a lot of these green squares.
Well,
Thank you.
what is funny about this is we discussed this before about what problems would be the most difficult ones, and I would like to point out that still until this moment A hasn't been solved.
Yes, that makes sense. I think it's easier than L. I'm surprised, but
Yes, well apparently the top team didn't think so.
okay. Well, they have strange opinion of what problems are easy. Definitely.
Yes, I also looked at that and also find it quite funny.
They started with really interesting set of problems, and well, where is the 6? Why all other teams
But,
stopped at
but
5?
fair is fair. I think the other expectation I was wrong. I said that the team with 9 problems will probably win.
Oh,
I think the top team might actually get to 10 or 11.
Yes, I think they have good chances now. So they have which ones? They have K, which is definitely solvable by a bunch of teams.
That team should definitely be able to solve it.
probably. So they should get at least it. And which one they don't have except two unsolved one? I don't remember.
I think
well.
they didn't solve J.
They didn't solve J. Well, J is a tricky one. It's only one team who solved it, I think, at the current point. And
Yes.
a lot of teams who attempted and
They
failed.
didn't find the real trick.
let's require some tricks, some knowledges. Oh, well, but they trying to solve K. But, well, it was slow and they got time limit.
Yes, time limit.
But what is time limit in K?
Yes, it's very nice if you manage to do a time limit on that problem. I think.
That's strange. Probably that should be some bug, not wrong solution. I don't understand. I think solutions are problem.
I don't think K is a typical time limit solution. No.
Well, I think yes. I see. I can imagine a couple of solutions which are too slow, but they are too slow.
Yes.
Like one can't imagine that they could pass. I don't know. Let's see. Probably they just have some bug.
That's very likely. Yes.
Okay. Well, that's interesting to check with them. So at least we know what they're working on now. It would be much more content if we would be able to check.
But if I look at the current results, it would make the most sense for them to work on K. That's
or
by
on
far.
J. Why not?
K is by far the most solved problem.
Including getting concern of all the history, how the contest was gone. I think the problem with which is G is the best for them. It would be better continuation of the logic they used before.
Yes, but if even the top team says, well, that's a bridge too far, maybe that says something.
Well, okay. I got some part of their solution on K, and it's written on Python. Maybe that's the issue.
I hope not.
Well, and I think it looks to be too long. I'm not sure. It's something strange. No idea. Well, let's see.
I have all the faith that this team will figure it out in the coming 2.5 hours.
Should be quite probably. Definitely have enough time for that. And by the way, what is your policy about other languages? Do you know it? So we talked about Python several times. Do you think that all problems should be solvable in Python?
Why not? I'm no language expert. I'm also not a computer scientist. I'm a mathematician.
Okay.
I grew up with Java. I know Java. I know a little bit Python, but other than that, I don't know anything.
Okay.
So I'm just here for the amusement of others, so to say. But I think most of the problems should be solvable in basically any language.
Well, that's just a time limit issue. Like Python code is 10 times slower than same code on other languages because it's interpreted.
Yes, but in most cases, Java is also very slow.
Not really.
There are some problems in which you...
there are some problems, but in most it's like 1.5 times slower, not 10 times.
Yes, but 1.5 times slower is still...
It's still an issue.
And I know that I actually know for a fact that some problems had the issue that when you work with a scanner in Java, for example, it's too slow.
Yeah, there are some issues.
Buffer reader, then it's fine.
In C++, there are some similar issues.
Yes.
That's okay. But
I mean, it's part of the contest. I mean, the play field is equal for everyone, so that's all good, all in the game, I would say.
Okay, that's really nice. Well, it requires a lot of effort in choosing problems to make them all solvable on languages. It requires a lot of effort on preparations.
Yes, but I can imagine, of course, you as a previous world champion, you know,
Yeah.
5 or 6 languages that you can all use at your disposal.
That's the point.
But I mean, most of the teams here, I think, can only use 1 or 2 languages because
I think mostly used one.
exactly.
But I think that there can be different policies in different judge teams. Like something that's only easy problems should be solvable on languages, and other are like how it go, or something like that. It depends.
Yeah, well, to be honest, I use the language that I know, and I even if some languages are easier to use for some problems, I wouldn't know.
Okay.
I don't have the
Makes
insight into that, and I think most people don't.
Yeah, like the problem. I mean, okay, I was talking on behalf of some
Yes,
organizer. I just about organizing policy, not about the actual
yes, but I don't think there is at this point a language barrier. I mean, I don't think.
Well, it's nice to not have it. That's definitely true.
Yeah, I think that's also one of the things that should be.
Not always possible, but very nice not to have it.
Yeah.
Okay, so do we have even more teams with 5 right now? Like we have 7th place with 5. So well, let's start with another prediction. How much problems would you need to solve to get bronze? That's even harder.
Well, I would say.
Would 5 be enough with good time?
I think I would say about 7.
So you think that we'll have 12 teams with 7 at the end? Oh, we have one more teams with 4.
But bronze means 3rd, right?
Bronze means 12th place.
12th place is
Yes.
bronze. Okay, then I would say then it's far less. Probably, I don't know what the current situation is for number 12.
It's a bit. So now 5 is 7th place.
Yeah, I would say probably 5 fast or 6 slow. So to
Okay,
say.
that makes probably it should be like that. So we have some teams which are probably already should be in medals, but
Yeah.
everything can go. 2 hours is a lot of time.
Yeah, but of
You can
course,
self-
of course, in this case, the number 1 is far ahead of everyone else.
Yes, but probably something can happen. So if they stop at this point, then well, having 9 from 5 for 2 hours is quite possible.
Yeah, I of course wouldn't advise them to just put down their pencils and their papers
Yes,
and
so-
go home and celebrate already
so-
on the way home. That's a little bit.
They have a lot of advantage right now, but everything is possible.
Yeah, well, of course, the advantage works in 2 ways. I mean, the first advantage is, of course, the score, in which you have an advantage. The second one is that there are less problems for you to think about.
And they will have really good penalty time, so probably it's already impossible to overcome them with 8.
Yes, but I don't know. I mean, you're of course far more experienced than I am in this case. But when you solved a lot of problems, then you start to get more and more focused on the problems that you still need.
Also sometimes.
So it's kind of a double advantage in this point, I would say.
Yes, probably it is. That's a good point. So one more team with 4. And maybe you don't know how many places, how many teams would advance to Enwerk.
I don't know exactly.
Maybe we'll find someone who knows later.
I think it's actually university based, right? So
Still. Okay. Oh, we have one team with 6 right now.
nice.
So it was solved problem D. It's University of Utrecht.
Yes. Yes.
They solved problem D.
To be honest, problem D is quite a surprise for me that it's not solved that much or yet.
Well, I think it just was solved too late. So there was like 4 problems which are
Yes,
definitely
and so
much
everyone
easier.
keeps doing that.
So everyone keeps solving them, then the scoreboard effect is quite big always. So the problems just need to finish the problems which was looking easier, these 4, and then started others.
Of course, D is interactive, so I wonder if that actually scares people away a little bit.
Well, it depends.
Because in my humble opinion, I think D is actually one of the easiest of the set.
Interactive problems require some a kind of different mindset.
Yeah, I
They
suppose.
require a lot of technical work. To be honest, sometimes it's really hard to debug interactive problems.
That's true. That's true.
So many teams doesn't really like them because of that. So it's different.
It's possible. Yes.
So I think it's making problem interactive, just like make it couple of levels harder. Like
Yeah, but in the case of D, that's the only difficulty in the set.
yeah,
the
probably
problem
it is.
because
I don't know. It's kind of unobvious in sense. Like you need to build some model in your head, which is like it's untrivial to understand what you asked.
yes, of course, that's the main concern. I mean, D has of course a very lengthy story that you have to go through.
As well, I was hinted that we have 2 teams per university, and maybe more depending on some stuff we don't know yet.
Exactly.
So
So you can say something about what teams will go based on ranking, but a lot of it will also be based on university.
But at least 2 teams per university is allowed.
Yes.
Okay, so main competition is inside university, in some sense.
Yes, but it's also I think this is pretty much the first test where universities actually see where they stand in terms of each other, so to say.
Yeah, which is quite nice because on Werk they will compete against each other, not against
Yes.
inside
So
university.
the universities that generally score lower now, that they at least know that they have some work to do in the coming weeks.
That's the big thing because like they have around a month, a bit more.
Yeah.
So let's say when you can improve in some parts, not too much, but can reasonably improve.
There could be time to at least practice. I mean, I don't know how the teams are formed, but I know from experience that not every team is already used to working together this intensively before.
That's really important because especially their study year almost started, like not too much time passed. So if you started in mid-September, for example, you just have 1 month, which is not much, and 2 months is twice bigger.
Yes, that's true. That's true. So it could be good to intensify the relationship within a team for a few weeks.
Yeah, so that requires to experiment with some options. I don't know. Oh, we'll have 1 more 5.
Very good. And also he solved D.
Yes. So in fact, we need that 4 is not a number for silver medal right now.
No,
Which was quite obvious, but anyway, from this point it's official.
Yes, that's good.
That's probably, and this means that
This
looks a bit faster right now,
And
so we can see how fast, in some sense.
this looks promising.
Yeah, but something went wrong on last cases, but they managed to pass. Okay, so that's 9-6 now.
Yes, well,
Which becomes much harder to overcome, I think.
yes,
Because I hope the second team would be able to get 9. They have enough time for that. They have 2 more hours for 3 problems. That is quite possible.
yeah, and of course
While-
they have been working on something already, and
Yeah.
that should give them an advantage.
While having 10 means solve at least 1 problem which is unsolved now, which is a big achievement.
But I think the only unsolved ones now are A and G, right?
Yeah.
Yeah.
So you need to solve 1 on them. Oh, no, it's not. You don't need it to have
They-
10.
They didn't do J yet.
Okay, but you need to at least solve J, which is solved by only 1 team now,
Yes.
or one of that 2 hard problems, which is much bigger for than just solved everything which is solved by many teams.
Yeah, that is true. So now they actually have to find their own way, basically.
Well, let's see what they would be able to do, and they definitely need 10 to overcome them because penalty gap is now too big.
There is no. They don't have to think about penalties anymore. They can basically,
Just overcome with 1 more problem.
yeah. If they solve something, then they're all good.
Yes, but okay, but maybe I think we'll get a bunch of 6 teams.
Yeah, I
Very soon.
would hope that the ramp up would be a little smoother now, because now there's a huge gap between the number ones and everyone else.
That
and
happens sometimes.
I think the gap will clear up a bit, so it will
I
become
hope
more of a difference, so to say.
Well, also some teams closing their beginner stuff. Like they
Yes, I see
They
all of them also solving F.
Solving F was the third problem, which is perfect, which seems
Ooh,
and
J.
J, but it's not working. Probably this problem wrong answer can mean almost anything.
Yeah, but I think the most teams will actually understand the concept of how to
Yes,
to
but
do it. But the
question is how to do it
essential
fast
first
enough.
step of randomizing is something that may not be so clear.
Yeah, especially if it requires some details, I'm not sure, because it may be important on how you process after randomizing. Well, there can be some details in this problem,
Yes.
which are not so easy. Okay, so can we take a look on scoreboards maybe, or just to check that? Oh, so we have a black star, black balloon watch. It's probably for problem C. I didn't seen it before.
I think it's for C, yes.
So what do we have is a lot of teams solving at least 3 problems. We have, I think, more than half teams solving 3 problems, which is great. And probably I hope that it looks like we have only 2 teams who really attend the contest and didn't solve anything yet. And probably we have several teams who just don't attend the contest.
Yes, that's true.
Okay, that happens sometimes.
But it looks like most teams will be able to solve B, E, F, and I.
That's good. That solving
Yes,
4
so-
problems is quite a good achievement.
So I would say that most teams will be able to reach the 4 before the end of the
Can
contest.
see that, but I hope they will. And so 2 problems are unsolved yet. Oh, we have 2 solutions on J right now,
Yes.
and that means that maybe some more hints for some problems.
Yes, I think out of the 3 problems left for the number 1, I think J is the obvious choice, to be honest.
Okay, I just checked the difference. What the top team solved in K, they just fix something. They just switched from hash table to list of lists or something like that.
Oh yes,
And
that could
sometimes
actually
help.
yeah.
Okay, why
And
not?
They were close at the first try, but no cigar.
Oh, just some constant improvements. Oh, we have a submission, one more submission on A from team in top 7.
Yes, I think there's
So
only
there's
there's only 2 or 3 teams that actually tried A so far, and none of them
I
have
think
managed.
there was 3, but anyway. So I think
4.
that's the 4th one. I mean,
But it's it's not trivial.
it's not a trivial problem, but I think it's quite possible. I think I'm a bit surprised why they're getting wrong answers. I think I expect more time limits on that problem than wrong answers. But okay, that happens. So one more team asking for their second problem. Well, so maybe any more backstage stories.
No, I don't. I'm thinking. No, I think everything really. There is going to be surprisingly few lessons to be learned from the things that happened this year, because there were not much large incidents.
I'm not sure if it's good for organizers, but it's definitely good for participants.
Yeah, but the risk is always of becoming lenient and lazy, and next year
Oh,
to
they definitely have enough problems.
yeah. True.
Oh, so the team was succeeded with second problem. We can congratulate them.
I think they fixed something really
They
simple.
fix him. Yeah, like it was too fast submissions. Well, not really much would happen now because teams are mostly doing some debugging or something. But
I think most teams will just fill up the scoreboard with the problems that everyone has solved.
that's an important part too.
Yeah.
But I think we'll see someone who do something interesting, like maybe the team. Well, I don't still remember the university. I think it was Balloon Addicts team.
Could be.
Oh. Okay, they just fixed what Toad put. That's an interesting problem. Okay. So, it's another team. This local team, that was not the.
Well, to be honest, one university that actually managed to surprise me a little bit today is the University in Nijmegen, Radboud. They actually have two teams that are performing in the top 10.
That's not bad. So maybe you can tell something about local teams. Do you know something about them?
Now, to be honest, I don't know much teams. I'm away from university for quite a while already. So
there was Eindhoven University team which started really well. I don't see them right now.
I know the top team from Eindhoven started really well. They were first for a while.
For three and maybe for 4 problems. They are 9.
Yeah,
right now.
so they solved 3 problems really fast and all in one try, and then it fell flat for quite a while.
But they have good penalty time, so that if they succeeded in
they gain a lot of ranks. Yes.
So they'll gain a lot of places because of really good penalty time with solving 4 really fast.
Yeah, but they should at least solve a 5th one and hopefully also a 6th.
Probably they need 6th one, but still. So can we maybe we can show the teams? So can we show some specific teams maybe or something? I don't know. Probably we can't. Okay. But so the team now is just not submitting anything for really long time. So hope they are preparing something for us.
But if I take a look at the top 10, I see a lot of Delft and I see a lot of Nijmegen.
Well, that means
that's really
some universities have some.
It's really surprising.
Well,
Especially, I mean, Delft is not surprising.
We have 3 Delft teams, I think.
Yes, and also 3 Radboud teams from
4
Nijmegen.
4 Delft team in medals.
Yes,
that's a really good achievement.
But in the preliminaries, they all scored very well in Delft, so that was to be expected, so to speak.
That's nice.
Nijmegen is quite surprising.
One more Eindhoven team solving 4.
True.
And which other university? I think Radboud.
Yeah, that's the team. That's a university in Nijmegen. Yes.
Okay, so they have 3 teams in medals, which is
really very impressive. Yes.
Okay, so I think that Delft University. It's another Delft University.
They managed to solve A,
and that's not Delft University on the top. It's another Delft University.
But they finally solved A. So
I think Delft University teams have some problems with problem order. But okay, why not? If it works for them, that's nice.
So that means that only one problem remains unsolved.
Well, and I don't think many teams have time to work on it because it really requires a lot of computer time for experimenting.
Yes.
And probably only team having it right now is the top one.
Yeah.
So that would be.
But you never know if there is one team on the lower rank secretly working on this problem for 3 hours.
Yeah, that happens sometimes.
You don't know.
It happens sometimes.
But it's good to see that most problems at least got solved once.
Yeah,
so they're actually solved.
We have all problems except one solved.
That's what was to be expected, I think.
I think, well, it's quite possible. Well, she looks quite possible too, but it requires a lot of time.
That's true.
By the way, do you know what's happening on team? Oh, by the way, we have not only the main contest, but we in parallel have contest for companies teams.
Yes, I've seen companies. They are actually doing quite okay. They're keeping up, so to say.
So maybe we can somehow.
I don't know if we can show it on screen.
Probably we can't show an overlay information for them because they're hidden for us. But maybe we can just discuss it generally. So how many do you know?
I think there's somewhere between 5 and 10 teams competing in
in
the company teams.
Maybe I can get a screenshot of scoreboard or something to just tell about what's going on with them. I hope I'll get it soon. So, and we can discuss what the other teams do. So that are the teams which are not training. They're just professional AT specialists who are just coding as their everyday work, but not really preparing for competitive programming.
Yeah, exactly.
So that's a lot of discussions if competitive programming really helpful at work, and how they're connected.
True.
But we can think about a bit of how these teams are performing.
And I know that there is there's also some spectator teams working. They started with a little delay. Some of the coaches are trying some of the problems themselves.
That's nice too.
And I know there is some teams that actually wanted to participate to see if they still could do it.
Okay, that's always interesting to test. Okay, so we're not get it yet. And so, do you know which companies are providing teams here?
Oh, no, that's a question I don't know the answer to really.
So I understand correct that it's mostly the sponsor companies?
It will, yes, most of them will actually be the sponsor companies. But to be honest, I don't know all of them.
Okay, we'll check it a bit later. So maybe it just can be found on BAPC website. It probably shouldn't because of... I'll check it first, but not really. Succeeded to found it. Okay, we'll discuss it a bit later.
That's fine. But you see the clutter of balloons starts to grow bigger.
And that's nice. Like
That's actually good.
Really, it's different teams. I see that one team with orange balloon. I not remember which problem it is, but it's something untypical. Maybe it's problem J. I'm not sure. We'll probably been shown the scoreboard.
I think it's H.
Oh, we can view on programmer on companies teams.
There it is.
So I've not really view them well. Maybe you can say it now. I see that we have a couple of ASML teams.
Yes, I see the ASML teams.
We have a couple of booking teams.
Booking teams, they also participate pretty much every year.
Probably don't have pro-drive teams.
No, I don't think they
didn't
actually participated
happens.
this year.
And what is IMC team? What's the company it is? I failed to see it.
I think they're doing quite well, solving six 5 problems.
So it would be second place right now in the main contest, I think.
Second or third, maybe.
It's second or third. I'm not sure about penalty time.
Exactly.
So and they are quite the same in problems. Oh no, I think they considering problem J as easier than
yes, which
other teams. So
yes.
2 teams solved of 2 of 10 teams solved problem J of 8 teams actually.
I think this is the effect of watching a scoreboard where someone solves a problem and it seems a lot more doable.
I think that scoreboards are. Does the team see them in scoreboards, or does them see teams in scoreboards?
I don't know.
Or they are totally separated. We have one more accepted on J, and it's now a team with 7.
Nice.
So they are getting closer.
They are getting closer. That's actually pretty nice.
And they are solving J, which is not solved by leader.
That's true.
So
That's true.
now they have some possibilities to.
But I think in the scoreboards, I think the company teams see each other. I don't think they
only. So there are 2 separate contests.
I think so.
Okay, I'm not really sure, but anyway, these 2 they're a bit disagreed on.
But they are doing pretty well. Oh, but the number 2 starts to walk away from the number 3.
Okay, so what?
So the number 1 has scored 9 problems. The number 2 has scored 7, and then number 3 has scored 5. So
number 3 scored 5 still.
yes. So
Okay, so now it's definitely number 3. But okay, so we have one more jury member.
that's very nice. And
Who
I will
want to
pass it on.
tell about one of problems.
I wish the teams still a lot of luck in the last
So
2
we
hours.
can probably return.
No, because I actually have to go.
Okay,
So it's good.
we can probably return to the main contest scoreboard then, and greet our next jury, our next guest from jury. Can you please introduce yourself?
Yes. Hi, I'm Reinier. I'm now in the jury for the second year, and I've also submitted some of the problems in this contest.
So which problems are yours?
So the problems are H, J, K, and L.
That's quite a lot.
It's quite a lot indeed.
Oh, and we have one more team with 6 right now. No, not got it, but they was quite looks quite close. So
Yes.
one of your problems also.
Mm.
You said.
Yes, indeed.
Okay. So which one do you like to
Yes, so now
tell
I
about?
would maybe like to discuss problem J, jagged skyline.
Okay, we have discussed it a bit, but with no digging into details. So it would be
Okay.
nice, because I think it's the best problem of the problem set, in my personal opinion.
Okay, thank you for the compliment. So maybe let me use the blackboard. Okay, so in this problem we have some skyline, and well, it's basically on a grid. So let me just draw something. Maybe there's another building here. And now this is an interactive problem, and there's some grid basically. Let me not draw it. And in this interactive problem, we can query some pixels. So this is an image with a height of at most 10 to the power 18 and a width of at most 10 to the power 4. And we need to find the highest building. And we can query pixels of this image, and then the interactor will return whether it's either a building or whether it's part of the sky. So we need to find the highest point, which is still a building. And maybe a first idea for solving this problem, or maybe I should also note that the amount of queries is only 1.2 times 10 to the 4. So we can use, on average, 1.2 queries per building. So maybe a first idea would to be to use a binary search on every column of the image. However, then you will definitely need more than 1.2 queries per building. So this unfortunately doesn't work. But maybe a slightly better idea is, suppose we have, so maybe first we do the first column. Well, if we find there's nothing there, then we do the second column. Then we find that here is the highest building. It's higher than what we found before. And then maybe we do the third column, and then we find this building. But now if we arrive to the fourth column, we could also just maybe query this pixel. And if we see that this is part of the sky, then we already know it cannot be higher than this previous building. So in this way, we do not need any queries for this column, which is nice because we only have very few queries. And using this idea, you can get the number of queries down a bit, but unfortunately it could be that still, if every building is somehow higher than the previously found building, then it could be that you still need to do a binary search for every column. So, but to solve this problem, what we can do is, instead that we do them one by one, we might just do them in some random order. So maybe we first start here, and then we do it here, and if we randomize this, somehow we expect that we do not need to increase the height of the highest building found so far very often. And this is the trick. So, and somehow if you want the formula, then how often do we need to increase the height? Well, it turns out that it's actually approximately the natural logarithm of the width.
Well, it seems it's quite easy to see that, because like each building should be the maximum. That means it should be bigger than E before them. So it's like 1 to the e's probability of that, and that sums to logarithmic value.
Well, no, so actually if you look at what is the probability that the nth building we encounter is the highest found so far, that's exactly 1 over n.
Okay.
And therefore, if you want to know how often this happens, you take 1 plus 1 over 2 plus 1 over 3. And this is some kind of harmonic sum. And therefore, we get this logarithm.
Yeah, that's really nice. And do we need some stuff like getting So it's multiplied by another logarithm of
Yes.
binary search. Do we need to optimize it to logarithm of actual height of the building, or just doing that is enough?
So actually, yeah, if you just do, so this would be times, say, the 2 log, because you need this binary search of say, the height. And this is good enough, actually.
It's just good enough. Okay.
This is good enough, yes.
I think I can optimize it like twice more or something like that. Not too much. Not asymptotically, but to make the constant bigger using some stuff like exponential, not just binary search, by exponential lifting, like checking, like stepping up by increasing size and then by decreasing back. It allows us if increase.
Yeah, it's something you could do, but for this
That's
problem,
not
it's
required.
not needed.
Okay.
No.
That's great. That's great. I was worried
Yeah.
about that. I understand that it's possible and
Yes.
totally unclear if it's needed. And I'm quite happy with it's not needed.
Yes.
Okay, thank you a lot. Maybe we can. Do you have time to have just
Yeah,
a talk?
sure.
So you can join us. So you said you prepared 4 problems for that, or just you prepared one but authored 4. How does it work?
Yeah. So, well, there's a call for problems for the jury. So everyone can basically submit these problems. Well, as long as you're not going to participate yourself, of course.
Makes sense.
And then you get some list of problems, and these problems are both used for the preliminaries and for the BAPC itself. And so the nicest problems are selected, or also the problems which make a nice problem set, so not all the same topic. And then these are made into these 2 contests. So I should maybe also say that in the preliminaries, none of my problems were selected, so somehow they all ended up.
But that means that, we got 10th problem from Delft
Oh, nice.
right now. So I think at that point they are almost unstoppable. I'm not
Yes.
sure. I'm quite sure that no one should overcome them, because it definitely would require 4 more problems. They solved not A, but J. So we have no unsolved problems now, which is
Wow.
really nice too. That's surprising. So in fact, probably that means that if one want to overcome them, it would need almost everything.
Yes, it seems like that. Of course, there's still some time, so a lot of could still happen, but it would be
they
very
have
difficult.
almost 2 hours, but
Yes.
it means that you need at least 11. That means 4 problems for the second place.
Yes, because probably the time score will not be enough
But
to.
11 means that you need to solve either A or G. But maybe teams of the third place have some chances because they already solved A, and probably they should be managed to solve I soon because it's not really hard.
Yes, perhaps. Yeah, I'm very curious what's going to happen, and I really don't know what will happen for the last part of this competition.
Oh, at
But
least,
I mean,
at least I think that competition for the second place is still very unobvious,
Yes.
and
Yes,
anything
indeed.
could happen.
Yeah, the
And-
first place seems.
Seems more or less decided.
Yes,
I would be surprised if it changed.
indeed.
But
But you never know.
yes, sometimes it happens. Also, which problems do you like most? You were a little bit surprised by me saying that J is my favorite one. What is your favorite? What is
No,
your
so
opinion?
actually, I personally also really like J.
Yeah, because
But
it's,
of course, it's a bit strange to say that about your own problem, maybe.
that's
but,
okay. I think it has an effect like you're surprised. When you're reading it, you're just how it's possible. It looks totally impossible,
Yes, indeed.
and that's the point I really like in this problem.
And then also, if you actually have found a solution to implement it, is not
Yeah,
very difficult.
that's true.
Yeah, I also think G is very interesting. It's also a quite difficult problem, of course.
Yeah,
Um,
definitely. I'm not sure if we can know if they submitted some normal solutions, just some random heuristics. Unfortunately, this kind of the problems sometimes have.
Yeah, so
That's
it's
really hard
supposed
to
to,
create
not be solvable by using heuristics.
Well, it's often really hard to create good test data for such kind of problems.
Of course,
So-
yes.
but I hope they just got the idea. Okay, so maybe you want to talk something about some more hard problems. So I think we just didn't cover most of them. Maybe you can talk about problem G.
Okay, sure, I can try.
Or any other complex problem we didn't cover it yet. You like?
Okay, no, I can talk about G for a bit. So let me quickly open it in the problem set. Okay, so in this problem, so where's the eraser of the board?
On the side.
So in this problem, we have a set of stones, and we also have we somehow want to divide these stones into groups of size k each, where this k parameter is quite small. So k can be at most 8. So let me maybe take the first sample. There we have stones of size 2, 4, 5, 6, and 7. And let me maybe, just to make it slightly more interesting, add some extra stones. So suppose I would add also 10. And maybe also, let me add 18. And we want to divide these into buckets.
Now not divisible.
Oh, that's of course a problem. So
probably you can use 14 instead of.
Yes, I think that's maybe better. Yes. So now we want to divide this into groups of 8. But maybe one trick we can apply is to see that dividing this set of numbers into groups of size 8, and we can cut up some numbers into multiple numbers, but we want to do that as little times as possible. So what can we do? Well, somehow dividing this set of numbers into groups of exactly 8, where you can cut up these numbers, somehow it's equivalent to just dividing the groups of dividing the numbers into groups of size divisible by 8. And we want to make as many groups as possible, but then we do not cut up the numbers, and then the result is exactly the number of groups we should get in total, which we can easily compute because it's just the sum of all numbers divided by 8, minus the maximal number of groups divisible by 8 we can get from looking at these numbers. So I will try to solve this alternative problem, and then we can always convert this back to the original problem. So then what's the first step? Well, if we want to look for groups divisible by 8, the first step is to just say, okay, we can reduce everything modulo 8. So 10, we can just replace it by 2. And 14, we can replace it by, 6. And now a second step is, well, suppose there would be any stones where the size was already divisible by 8, we could, of course, just put them in their own group, and that will be optimal. But also, if there are somehow 2 stones, for example, this 2 and this 6, their sum is exactly 8, and it turns out that it's also optimal then to put these together in a group. And then we can basically remove these from consideration. And maybe let me check. So we also have this 4 and this 6 here. So let me also remove those.
4 and the 2?
Yes, of
6
course.
and the 2. I mean 6 and the 2.
6 and the 2, yes. Okay. And now we are left with some smaller set of numbers. And it actually turns out that if we do that, and if the sum is at most, the desired sum is at most 8, then we are left with at most 4 different numbers. So in this case, we have 3 different numbers. Because if we would have more than 4 different numbers,
probably we even left with 3 different numbers and maybe 1 4.
Yes, and indeed. So this 4, we can never have 2 4s because then we could cross them out with each other. So indeed, 3 different numbers and maybe 1 4. Maybe that's a better way to say it. But then, of course, the problem is, okay, because it could be the case that we have maybe a lot of one single number. So how do we handle this? Well, and so now to solve the remaining problem, we want to use dynamic programming. So maybe let me again make this problem slightly more interesting by adding some extra numbers, but then you have to check that I'm still keeping the sum divisible by 8. So maybe let me add, okay, so this is, if I add 5 and maybe say 3 ones.
Okay. Why not?
Oh wait, this is of course not possible with the 7. Okay, so let me again remove the 7.
Okay, why not?
Okay, so suppose we have these numbers, and now we want to do dynamic programming. So what are we going to do? Well, we want to somehow find the maximal number of subsets, disjoint subsets, where we can get sum divisible by 8. But we can somehow rearrange this data. So maybe we say, okay, from digit 1 we have 2 numbers, and from digit 4 we have 1, and from 5 we have also 2. And now what we can do is for every subset we can try answering this question of what is the maximal number of disjoint subsets which all are divisible by 8. And now this turns out to have a very simple recursion. So, well, what is the number of subsets of this group? Well, we can check what is the number of these subsets if we would remove one of the ones. So, wait, maybe this is a bad example. So maybe I should try this bottom up. So suppose I would have, say, 1, 1, and none of these two. Well, then obviously the answer is 0. Okay, so now you should check whether this maybe actually has an interesting answer. But somehow the idea is if we would want to check this for some arbitrary set, one for example this set, then if we know the number of subsets in all the other multisets where we remove one of the numbers, so for example with 1 1, 1 4, 2 5s, 2 1s, 0 4s, and 1 5, and we can also try it for 2 1s, 1 4. No wait, I should here put a 2.
I am a bit lost at this point.
Okay, maybe
so
it's...
can we try... So, do you understand correctly that you're trying to find a one subset and subtract it, and then again already calculated value by dynamic programming? So the question is how to find all ways to get one subset.
Yeah, so that's indeed one possibility of solving this. We can... And then actually the answer is we could try all possible subsets which have a sum equal to k. We can brute force it because they're only...
Not only equal to k, but to
or
k,
divisible by k.
And the question is why there are not too much of them. That's probably the only question. Probably can have 33 insert options here.
Yeah, so...
Do we need to consider something?
So, of course, the thing is that if
we
you...
already have 5 teams solving 6. Which is
nice. So, maybe an observation to make is that if we look at one such a subset, we only need to consider somehow minimal subsets. So, if, for example, if k equals 8, then, of course, a subset with 16 times the number 1, it will be divisible by 8, but it's very non-optimal.
Yeah, that's quite useless.
So we only want to consider subsets, for example, where each number is used at most 8 times.
Okay.
And then if you do that, actually the number of subsets will already be quite low.
Yeah, that's
and low enough, which makes it possible to brute force this.
So let me summarize the solution.
Yes.
We first use some greedy to remove the obvious part of the stuff.
Yes.
Then we'll add with 3 buckets and maybe 1 4
yes
to everything else, and then we need to just check the options of the first. So it's now we have at most 33 insert options up to this 4.
Yes.
And then we need to check 8 to the 3 to the power of 3 options of what to get from them, and that's not too much already.
Yeah, so I'm not exactly sure what the details are, but it could also be that before you check all these 8 to the 3 options, you of course only need to check the options where it's actually divisible by k,
so it's
and you only
8
need to
times smaller of them.
You can also have some further reduction where you only check the subsets which do not contain some smaller subset,
Okay.
and if you do that, then it's fast enough.
Oh yeah, looks possible on the one side, but
But of course, there are a lot of steps to go from the original problem
and I think
to.
it will require a lot of computer time for experimenting with that details, understanding how
Yes.
many of something you have, and probably not many teams will have this computer time now, but still.
Yeah, but it could be possible.
Well, yeah, I think it's a property of a good problem when you are able to understand solution when you get it, because it's easy to make a hard problem which no one can just understand the solution. Like
Yes.
get any scientific paper, and you are with almost unsolvable problem. But that's not a good problem.
No, not for such a competition.
Yeah,
That would be.
that's a good competition hard problem which you can understand. So thank you a lot for
No problem.
that. And maybe we can, as you wish, you can just say something more, or you can join me for discussing the scoreboard, or you can return to your
I will.
business.
I think I will return to the rest of the jury.
That's, of course, important too. So maybe some final thoughts for audience. I don't know, anything you want to say.
Well, so I don't think there's really
Okay.
anything to say.
That's okay too. So we can look at scoreboards now. Oh, one more team solving 2. That's beautiful. So what do we have in scoreboards right now? While I hope we're waiting for one more guest. I have no idea who can it be, but I hope we'll get someone soon. So we have one team with 10 problems, which is almost definite winner of the contest, but who knows? And we have quite a big options for the second place, like one team with 7 problems and a bunch of team with 6 problems with some trivial problems solved. For example, I think teams who had solved problem A had quite a good chances, at least for the second place. So what's going on next? So I'm not sure what are teams working on now. I think the teams on the first place should be working on problem J, but well, problem J doesn't require much work on it. It's required just coming up with solution, and then it's almost done. And if they don't, they don't. While problem A have a lot of tricky parts, which can be hard too. But I personally, I would bet they would solve A at some point, but we'll see. So I think the main next competitor is the team which solved problem A, because other problems looks to be easier. So it's another Delft University team, by the way. Delft. So for now we can have a break for a sponsor video, for one more sponsor video, and then we'll return, discuss what's happening. And we are now back with our new guests from Booking. So can you introduce yourself?
For sure. Hi, I'm Gabby, and I'm an early careers specialist at Booking.com.
Hi everyone, and my name is Andrea, and I'm an early careers recruitment lead at Booking.com.
So can you please say what you are doing in Booking and why you're here, why Booking is interested in these contests? And
etc.
For sure. So we're here because we're hiring for our graduate program. And more importantly, we're just here to meet a ton of bright students and let them know that Booking.com is hiring students within this field, and just to kind of cheer on the students as they complete the contest.
Yeah, and two of our company teams are also competing today. So we held an internal BAPCA internal contest, and the two winners are here with us as well, so they're competing. So we're rooting for them, and then rooting for all of the students that are competing as well. And yeah, like Gabby said, we're looking for software engineering students and data science students that want to join us for internships and full-time roles.
That's really nice. So why do you think that competitors on the competitive programmers, what can they do in Booking, well, generally? What kind of work you suggest to them?
Yeah, well, there's a lot of fields. And I think when people think about Booking.com, sometimes they don't necessarily think about all the different departments that we have. So we have everything from, back-end, front-end, full stack, fraud. We have an interesting fintech business unit as well. So there's a ton of work to be done with all of the verticals and all of the products that we have. So everything to do with, from accommodation, that's your hotels, your department partners as well, through flights, through car rentals, and through attractions. So throughout all of our verticals, there's opportunity for, software engineers and data scientists to join us. I think the majority of our company is composed of, people that come from STEM backgrounds within software engineering as well. So there's a lot of work to be done, and the opportunity to have real impact. So the students that join us go into a specific team, and they're able to really help their team, develop projects that they're already working on. So you see the impact that they have, and and that's why we're here. It's meeting interesting students and cheering for them as well.
Oh, that's really nice. By the way, I have a small stop that during we had help. Can you please show the scoreboard? And we have a team with 8 problems right now, in the second place, and one more team with 7 problems. So they're getting closer to our top team, which is still doing something. They just not stopped, but they're trying to solve problem J, but not succeeded with it. Well, we'll see what's happened. So
that's super exciting.
Where do you have your offices?
Yeah, so our main headquarters is located in Amsterdam in the Netherlands, and then we have offices all across the world. But for our early careers roles, so our graduate roles, they're mostly based in our Amsterdam office, and then we have some in the UK as well, in Manchester.
So if it's in Europe, it's mostly Amsterdam.
Yeah.
Yeah, for software engineering, yes, it would mostly be Amsterdam or Manchester. That's the biggest offices. And then we have offices all around the world, but a lot of those offices as well are mostly then for account managers and people that will go in and meet with different partners for hotels, and that's how we mostly operate.
Okay, so it's not really far from here. It's like 1 hour train.
Yeah,
I bought it yesterday.
Yeah, exactly. Yeah, we took the train this morning, so it took about an hour and a half, I think.
Yeah, it depends on which stations.
Yeah. And we're opening up our campus that's going to be next to Amsterdam Central. So it's going to be a really big campus that's going to be open by the summer. So it's going to be, it's going to be massive.
Okay, so I don't know what to ask, to be honest, but maybe you can just, do you have like only full-time job, or maybe you have some internships?
Yeah, so right now we're focusing on our graduate roles, which are permanent roles for students that have just graduated. But we're also looking at expanding to internships as well, and those would be in the summertime. But we do start the hiring for our early careers roles in December, and the program starts in September of 2023.
So it's quite soon.
Yeah, it's coming up.
Yeah, it's really coming up. And the recruitment process is fairly straightforward. We do like a HackerRank test, and then a recruiter call, so it will be with either of us, and then a cool in-house assessment day. So it'll be, you know, very interesting to be with all of the students, 2 interviews, more of a cultural fit, and then 1 peer-to-peer coding interview. So if you're already comfortable in the technical setting, this will be, you know, a nice way to show your technical skills. And then after that, you would get an offer within a week or so for a spot in our
Probably
program.
participants of this contest should be quite good in
Exactly.
Exactly.
Exactly. Yeah.
Yeah. This will be, and it's been really nice to meet a lot of the students that we've worked with through the different study associations too today, that we've met with lots of students from different universities all over the Netherlands. So today's been really fun to meet all of them and a lot of the participants too.
Also, well, I think the main audience of our stream now is coaches. So maybe, I don't know, maybe we have something for coaches, like some study programs, or I don't know.
Yeah, for sure. Do you mean like students that have already graduated?
I mean, that most coaches are university teachers.
Okay.
Maybe, I don't know, you have some
Okay,
educational
so you
programs
mean-
for them, or I don't know.
You mean like a collaboration of maybe imparting a workshop in the
I don't know what you have.
So
You
what
know
we
it's much better.
what we sometimes, of course, come to competitions like these to meet with students, and a lot of the times what we usually do is we go to different universities, and we normally bring software engineers that could talk about more technical things with the students. We are having a couple of cool events, like an event to teach the students how to do a technical interview for a company that they're interviewing for, so that the students are more comfortable understanding what companies expect out of a coding interview. We're doing different types of workshops. So for coaches that are, university professors or anything like that, if they'd like to collaborate with us, we're always very open, from imparting workshops, from mentorship opportunities. And if the students generally have a curiosity on a specific topic within what we do, anything from software engineering, machine learning, anything that they're interested in, we can always find a way in which we can collaborate.
So if you're a university professor who are streaming us, you know who to find this evening.
Yeah, exactly. We'll be around.
Yeah, and you can always reach us at graduates@booking.com for more information.
Indeed.
That's very nice. Maybe you can suggest some other stuff you want to talk to the people I didn't say things about.
Maybe I would just say that when this type of experience in a contest like this is super valuable for what we're looking for in students and grads. And so don't be afraid to showcase this type of experience. Like, even if you're not a top team, just the fact that you've made it this far is great. So highlight that on your resume when you're applying, because it shows that you've gone kind of above and beyond just your regular studies and really shown initiative. So I think this is really a valuable experience that you can bring forward when applying to internships or graduate roles or any type of thing like that.
Yeah, that's a great point, because a lot of the time students do ask us, how can they highlight more things on their CV or become more competitive when applying, even though maybe they don't have too much work experience. But these type of experiences are crucial, and I think this is something that if you do highlight it, it creates a wonderful impact on top of what you're doing for your university courses. And I think it will be valuable, and it will be nice to see some familiar faces from who we meet today applying for our internships or our programs. We'll for sure remember you when you apply.
Yeah. Maybe Andrea and I can share a couple things about what we like working at booking.com.
As you wish.
Yeah. I just really like how diverse the company is. I relocated to the Netherlands from Canada, and our team, I think we're at almost 17 or 18 people now, but we're all from different nationalities. There are a couple duplicates, but it's just so wonderful that you can be part of a team full of all different people, and it works so well together. So that's a really fun part about working at booking.com, is just how diverse the teams are and how welcoming and supportive everybody is.
Yeah, I was very pleased when I joined as well to find the collaboration and how, it's just super, super diverse. I'm originally from Mexico, and I relocated to the Netherlands about 3 years ago. And within our team and within Booking in general, there's so many people from different nationalities. And one of the things that I absolutely adore is that people genuinely love to travel, and that I love to travel. So it's really great to see that what we do actually impacts travelers worldwide, and that us as employees also generally feel a passion for it as well. And and of course the discounts we get from and the benefits we get from traveling never hurt. So it's a fun work environment. I think it's an environment where people can generally feel comfortable speaking their mind, and really we value all the input that all of our team members have. So it's a nice work environment that I am really happy there.
Okay. So we now have the team with 11 problems in our contest,
Wow.
which makes them almost unreachable. So you definitely need to solve every problem to overcome them at this point.
Wow.
And this doesn't seem really be possible to any other team right now, but we'll see.
We'll see.
But I will be even more surprised than before if someone. So Delft University shows it really well today.
Nice.
So then the third team is from Delft University too, and they have even 4 teams in top 8.
Yeah.
That's like every second team in top 8 is Delft University team, and now 3 of top 4 teams after one more Delft University team solves problem A. We have now 3 teams of Delft University in top 4. That's a great achievement.
Yeah, that's great.
Normally, how many problems do the teams manage to solve?
Well, it depends on how hard the problems are.
Yeah.
It depends on some contest structure. For example, like because of COVID restrictions, some contests gone to three computers per team formats, and you have more problems because you have more computer time.
Yeah.
And it depends. Problems can be harder. Well, for example, in World Finals I won, we had only 7 problems because it was
They were really hard.
They were really hard, and like.
So you won last year for that?
No. I won in 2014.
Ah, wow.
Quite a while ago.
Very cool, though.
Well, okay, and we have our more jury members who want to say something more. Okay, we have more jury members. That's always nice.
Okay.
So thank you a lot.
Well, thanks for the
Thank you
chat.
so much.
Thank you for sponsoring. That's always cool.
Our
And
pleasure.
so nice to meet you.
You too.
And
Thank you.
If you want to say anything more,
Thank
you're
you.
free.
We can pass it off to the
Yeah.
next speakers.
Good luck, everyone. Thanks for having us.
Thank you. 11. Did you? Okay. So I think you was already introduced to the stream, but for those who are not watching us,
Yes.
the whole time,
I guess I'll quickly reintroduce myself.
will you please reintroduce?
I'm Ragnar. I am longtime BEPC jury member and not head of jury anymore, but I used to be. And I will quickly explain problem L. I believe you didn't get an explanation for this yet, right?
I think we didn't. I think we didn't.
Okay, that's good. Like
We discussed that options we have, but
where
not
is the
dig
eraser?
Dig into details. So that's the problems you prepared, or just the
L
problems
is
you
one of the
liked?
problems I worked on, yes.
Okay.
I don't think I was the one who authored it. I don't exactly remember who did, to be honest. So the idea of this problem is that you get, I think, 100,000 points in 3D space, and the task is to find the closest pair. So you just get a lot of points, and you have to find the closest ones. And so let's just draw some points, see where this gets us. And in this problem, it's actually quite important that the input is random. So if this were a 2-dimensional input, it's kind of a classic problem, and there's all these kind of line sweep algorithms that can do this in something like n log n time. I believe this can also be done in 3 dimensions, but they are super complicated and annoying, and we don't really need them here, because these line sweep algorithms, they are worst case runtimes, but our input is guaranteed to be random. So actually everything will be super nice if we just kind of take something that works on random input. Let's see where to start. There is actually like a handful of different solutions that work on this problem. And I'm thinking, if we should start with the intended one, I think we should. So let's put some numbers. Our space has like a dimension 10 to the 18 cubed, I believe, or is it 10 to the 9? Can we quickly check? I think 10 to the 9 probably. Yes, 10 to the 9 cubed. And so all our coordinates are less than this, and the number of points equals 10 to the 5th. Can we remove this chair, maybe? It's a bit annoying.
Yeah.
So a naive solution that was tried a lot in the beginning of the contest is to just try all pairs of points. So then we get something like n squared, which is 10 to the 10 operations, and that's typically too much because a computer can only do like 10 to the 9 operations per second if it's very easy. And these operations are not very easy because they involve a square root, so it's not great. So we somehow need to try pairs of points, but not all of them. And one idea we can come up with is that we only try pairs of points that are close enough together. So if we have some points, I'll draw an example in 2D, it doesn't really matter, the 3D will be equivalent. We can just say we partition the grid into some number of boxes, and we'll talk a bit about how large these boxes should be later. And I would just try to find all, okay, let's assume there's another point here, then we have 2 points in this box. So within each box, we just iterate over all pairs of points. So if we choose the box size to be B, then let's do slightly different. Let's say we partition it into B boxes, so we have box 0, 1, 2, up to B minus 1 in this dimension, and then box 0, 1, 2, to B minus 1 in the other dimension. The total number of boxes will be B cubed. The total number of points in each box, on average, will be n divided. I need a new thing. N divided by B cubed. So if we choose B to be 100, the number of points in each box will be actually only like, this will get to 1 over 10. But it's very unlikely that all the boxes will exactly contain at most 1 point. Because of the randomness. It's very unlikely that all of them end up in different boxes. So if we choose box size 100, we get actually, on average, at most 1 point per box. But there will be boxes with 2. And it's very likely the answer is one of these pairs of points that ends up in the same box. So now this algorithm is actually almost linear because the number of boxes is like 1 million. So I guess it becomes, runtime becomes B cubed, so 1 million. But this has one problem. It could be that the closest pair of points is actually not in the same box. So one way to fix this is we take all these boxes, but then for this box, we don't only compare it to the points inside this box, but we compare it to all the points in the surrounding boxes as well. So then we avoid this issue where points can be on the boundary of boxes. So now for each box, we have to compare it to 27 3-cubed other boxes. And that is one accepted solution. And it doesn't really matter that much how large you choose B. It has to be large enough to get the runtime down sufficiently. But also if you make it too large, then the answer will not be found. So that's the first solution. There's actually a slight variation of this where you can also just only consider like these kind of 2x2 regions of boxes. But in this case, you have to be a bit careful because if you now only compare the points in this box to these other 4 boxes of points, it could be that the optimal solution is this point here. This point here and this point here. And then the optimal solution would not be found if you only consider the boxes right and above it. So either you choose a 2x2 window and compare all points pairwise, or you could choose one box and compare it to all points in the neighboring boxes. So this is kind of the intended solution, but there's a lot of variant solutions that actually turn out to be a bit simpler in my opinion. One solution I saw was using KD trees. You can do that, but then you need a KD tree implementation and you need to think hard. So, I mean, you can, but you don't need to. Let's draw some more points. So another solution that's kind of typical of geometry problems is to do divide and conquer. So we can divide everything in a left half and a right half and do this recursively. So then we get this interval and this interval. And then once the window becomes small enough, we can just brute force it. And otherwise, we can say that if on this set of points, we have a pair of points with distance L apart, and in this right set of points, we have a set with distance R apart, we know that the answer for this left half is the minimum of L and R at most. So let's say that's L for simplicity. Then we can say, well, we didn't consider the option yet where 1 point is on the left and 1 point is on the right. But because we already know that the answer is going to be less than L, we only have to consider points that are within L of this boundary. Because if it's farther away than L, it can never be less than L away to a point on the right half. So in this divide and conquer step, first you split, and then when you merge two halves again, you already know the partial answer, and you can use this partial answer to bound the amount of work you need to do to merge them. So you already have them sorted by x coordinates, so it's kind of easy to find the interval of points that is close to this boundary. And then you just brute force all pairs there. And the higher you go up in this recursion, the more precise your answer will be. So even though there's more points to consider, actually, because the answer becomes more precise, overall this works out fine. But now we still have this divide and conquer stuff, which, I mean, it's fine and it's nice, but also we don't need this divide and conquer stuff. We can do something simpler. So actually, because of this random input, we can infer that the answer is at most like less than 1 million. So let's assume that the answer is, let's assume it's 1 million, but this is actually, way too large. Normally it's more like 500,000. I've never seen it above 700,000. And the maximum x coordinate is 10 to the 9, and the number of points is 10 to the 5th. So the average delta x, like if you sort them by x coordinates, the average difference between two consecutive points will be 10 to the 9 divided by n, so that's roughly 10 to the 4. So this means that if you take all your points sorted by x, and now we take a window of size of 100 points, then the expected distance between this x-coordinate and this x-coordinate is 100 times 10 to the 4, so that's 10 to the 6. And that means that in this window, if you go from the left to the right, you are already much larger than your expected answer. Like if the answer is 1 million, this may work, but it will be less. So if you just test all points of at most 100 positions apart after sorting by x-coordinate, you will always find the answer. Actually, this is what we had as a jury solution, but then one team had a slightly nicer variant where just like in this divide and conquer solution, you can keep a running answer. So you just initialize this to infinity, and then every time you add 1 point, you check all points on the left and the right where the x distance is less than the current answer. And this is sufficient to solve the problem. So really all you need to do is sort by x and do one small optimization or one small brute force search, and that's it.
Well, I think this is quite a good solution even on non-random point set, but not sorting by x, but instead sorting by projection on random line.
Yes,
I think it should be. Well, it should be it's subquadratic.
I haven't thought about this much, but yeah, this sounds very reasonable. I agree.
I think it's probably like n square root of n on 2D, and I'm not sure if it would be.
So you do n square root n iterations, or you need square root n window size roughly.
Total time and
square root of
n. And I think it would be. I'm not sure if it would be n to the 5/3 or to the 4/3 on the 3D.
Yeah.
And I have no intuition about that.
I mean, I guess n times cube root n would still be fine here. That's kind of what you're doing here.
Unfortunately, it can be n times cube root n squared,
and then,
which is strange. Okay.
But and also we saw some teams that, like, in practice, you only need to do this along one dimension, but some teams did this for both x, y, and z. So they have 3 times the runtime, but a bit more guarantee that you find the random answer.
That's really nice.
Yeah. So actually one tricky thing with this problem is that there are some values of b where you are still kind of fast enough, but you solve all the test cases in the problem set with probability roughly 50%.
That's not
It's not ideal, but I mean, this is a price we have to pay for this problem. It's also a risk you take as a team. Yeah.
That's so would you want to tell anything more about that?
Well, about this particular problem, I think I've said a lot.
Okay,
there's just a lot of solutions, and
thank you a lot. That was an interesting editorial.
Okay, you're welcome.
We're having freezing started, and one next guest, and we have our next guest. So can you please enable a scoreboard?
All right. See you later.
So what's happening now? Now we having some submissions. Yeah. we're now having some submissions which with results we are not know yet. Like some teams submitted something and just got no, and the teams got their result and we don't get it. So we only can see that they are submitted several times and can speculate on this. Like probably the team submitted once and not submitted after it is probably solved, but it can be different. While like I don't know, team submitting 4 times, probably at least not solve it in first 3 times. So it's become a bit less information we can talk about, but still some speculations are possible. And I think that it's become frozen a bit earlier than it should be, but okay, but when it did and did. So can you please introduce yourself?
All right, my name is Lalit Sai, and I am the food coach.
So which one?
FU Amsterdam.
Okay, so it's University of Amsterdam.
No, Vrije University.
Vrije University. Sorry, but that I'm not really familiar with
Yeah.
local universities. So how are your teams today?
I think they're doing really well. I think this is significantly better than last year. And if everything goes according to what the scoreboard says, we might be looking for 2 teams to get medals.
That's really a nice result.
Yeah, and it was the same thing for our preliminaries. This year, it was a lot more competitive, especially during the scoreboard freeze. We saw a lot of jumping, last-minute comebacks, and I believe a team jumped from like 5th to 1st place. It was amazing.
Happening. That's why the freezing exists.
Yeah.
And so, did you participate it yourself before?
I did actually. I did participate this year in the preliminaries. I came 6th. Fortunately, we were only allotted 5 teams. So
you are both participating in coaching. How does it work?
Oh, participate as a coach?
Hey, so why not? But so your students overcome you.
I guess, yeah.
It's always nice result as a teacher. Like, okay, so I don't know what's why you're teaching. Why you start teaching?
I am not a teacher. I'm a student, and as a coach, I am representing the university and bringing the teams here.
So you have some. You're just organizer, or
yes, we organize the preliminaries.
Okay, and so who teaches your students to helping them get better? Is it your work, or you have some?
Usually, it's just the students on their own, and we just help organize venues and events for them. We organize hash codes events, and we just make sure that.
Do you mean Google hash code?
Correct. Yes.
Okay, that's.
And we just make sure we give them as many competitive events as we can to these teams.
Nice. That's all. Practice always makes you better.
Yeah. But mostly, from our perspective, we're just looking to get as many teams as we can. I think that was for the last couple of years. But this year, as I said, it's a lot more competitive, and it feels like teams are actually...
Well, having many teams makes well, there are different stages when you can stop, and not starting is quite a stupid stage to stop.
Yeah.
So then making a lot of teams, you prevent at least from this, which is nice. Okay, so can we check a scoreboard on these teams? So I see that where it is, it seems on the 9th place.
Yes.
I'm probably missing one more.
9th, 13th, and 14th.
13th. So they need to solve one more problem.
Just barely inside the bronze.
Well, that's. Well, you see that a lot of teams trying a lot of problems. So at least they are trying to fix their. So the teams on 13th place, and they already had some submissions.
I see 2 submissions.
So they had 2 submissions on I. I'm not really checked when they were, but.
Looking at I, there is a lot of submissions on I, so I guess we can be.
I think in I there can be a lot of precision issues. Strange, they're often noisy. Like it can be hard to get with them correctly with them.
On hindsight, the teams do not know if this answer is correct during the freeze.
No, I think teams know, but we don't know.
Okay.
So teams know only their answer is correct and not, and don't know if other teams solved problems. So you know if you have solved, but you don't know how much you need to solve.
And we currently have a total of 5 teams, and as you can see, the top 3 teams are here. We have one team at number 21.
Well, it's still a good result. So they have solved 4.
Surprisingly good.
This means at least they have solved all problems which are kind of easy.
Yeah.
But that's already a result.
Yeah. And our last team
So-
is in 26.
So how long they are training for now?
Training for the BAPC.
I mean, when they started participation in competitive programming like contests.
That it depends on the team. Teams like Drive 2011, they have been competing since the past 2 years.
That's
And
quite a lot.
They've had a very good results every single time. I think they were in the BAPC. And STD string name, I don't.
Well,
I thi-
they have some complex name which we didn't fit into the scoreboard. It's
Yeah.
becomes well. You
I
see
was
that some
confused,
teams you see that some teams are a bit compressed,
Yeah.
and when team name is too long, it becomes too compressed to be readable. So we shortcut it a bit.
STD string get name is also did very well in our preliminaries. They also participated last year's, but I believe one of the teams or 2 of the teams are first year students.
And so
which
for
is-
first year students, that means that they are participating for around a month.
Yeah.
And like even solving 4 or 5 problems is a great result for
It
them.
is very good, yeah. And yeah, I think when STD string get name, they won our preliminaries last year as first year students.
Well, I think they stuck on 2 problems now. Maybe then
Number
even-
9.
and if they solve both, they have wrong submissions on 2 problems.
Mm.
And if they solve both, they can become second. which
Yeah.
It's not bad.
I do not see it.
Well, unfortunately, it's a bit scrolling a bit
Yeah.
fast, but that's happened. So they
Monkey IQ 200.
have, they
I
have
love that
some
name.
wrong submissions on problem H and wrong submissions on problem I. Both of them are solvable, as we see, and maybe we'll be able to fix it for the last hour. Fixing problem is easier often than writing it from scratch.
Yeah. There's always that one edge case.
Not always, but quite often it's easier. And although we have 2 teams which are submitted their 8th problem and waiting for.
I see our last team, number 26, they just submitted A.
Well, that's an interesting choice of 4th problem, but as we see, it's always is possible. I think the first team which solved A, it was 5th problem for them.
Mm.
So, well, A is quite technical, but not too hard.
Yeah.
So if you got to it, it's possible.
And
And so, what you can tell about maybe some other universities teams, like
from what I know, TU Delft did very well last year in the preliminary.
which ones?
TU Delft.
Yeah, that we all
Yes.
we all see that TU Delft now have 3 teams in top 4 and the 4th team in top 8, which
That's
is
good.
really good result. But it can change.
I'm just waiting for Drive 2011 to
That's-
give more problems.
I hope they will. So it's one of your teams. Or
Yes.
Okay. Oh, so it's the Monkey IQ.
I really like that
well,
name.
reading these names are always hard.
Monkey IQ 200 combined.
Okay.
They haven't submitted anything, so.
Well, 203 is not too much. So well, we see. But by the way, we see that both teams who submitted the K as their 8th problem resubmitted it. So they.
Oh, I see.
So
yeah.
nothing. So it didn't go too well, but. So UVA is another Amsterdam University. Okay, I'm stop messing them at some point. Sorry for that. Okay, so maybe we can tell about your experience as ICPC participant, or what's motivated you to be here.
I first heard about this competitive programming thanks to something that Delft organized. So we also organized that for first year students. I believe it's the FPC for them. For us, it's the app junior edition. basically we organize a small 3-hour competitive programming events for first year students. They actually had a proposal that every other universities could do it. And that's how I first got into competitive programming. I really liked it. I sent an email to our committee, the one that organizes that, hey, I'm interested. I want to help. And with that, here I am.
Yeah, that's good. So do you know if every university now organizes preliminary contests?
I think that's usually the standard, but
So why the university which is not doing it yet should start doing it?
I think it would be a better judge on what team to send to the BAPC.
Also, I think that one more reason, it's just easier for teams. Like going to another city is quite a big effort anyway.
Yeah.
And when it started with, okay, you participate something locally, hey, you're a winner. That's much easier. And just to come to your university and participate in something. So if you are not participating, not making your preliminaries by some reason, choose a good example and start doing that. It's not as hard. You just need to write an email.
Oh, I think
not
that
really, but
one of our teams submitted problem I.
Yeah, and teams on the second place submitted problem I from Utrecht.
We don't know how I is.
Oh, I don't know what's happened next. So I is tricky problem. It have a lot of wrong answers.
Oh.
But we'll see. So
do we know when the contest is going to start?
Well, the contest
is
45 more minutes.
Nice. Okay.
And so we can tell a bit about what will happen next. So we will not receive any more results anymore. But then after the contest ends, there will be a small break, and then there would be a closing ceremony, which would reveal the result of these submissions, and we'll see who has solved what, and check what the final results are. I think we would stream this too. So if you are not able to join us physically, you can join us on stream and check this resolver. So do not forget to do it. It's the most interesting part for looking.
Definitely the resolver.
Yes, and so anything you want to suggest more? I don't know.
Let me see. Yeah, no, I'm just really happy that our team is doing really good in this BAPC.
Really nice. So
yeah.
Good luck to your teams and your future. By the way, I'm now living in Amsterdam, so you is kind of closer than other universities.
We're always looking for jury members.
So you can get in touch with me and we can discuss it.
Absolutely. Yeah. And hopefully next year's and like in the upcoming years, we can do even better. I'm very confident.
So we have a submission from top 1 team.
Again.
Problem A.
Oh, okay.
The first submission for problem A, at least we didn't see in scoreboard.
I thought it froze because they submitted it.
Well, I'm not really sure. It's maybe there is some bug in our software which loses this submission, or maybe, well, I even didn't know there is such a rule that if team submitted their last problem, it's become frozen. It's a bit strange for me.
Maybe they resubmitted it.
But anyway, if they resubmitted it, probably at least the first submission, if it exists, was not correct.
But they still don't know if it's other teams still don't know if
maybe
it's
this
correct.
one is correct. Who knows?
We won't know. We will never know until the end.
By the way, we can show the scoreboard we can also have some what if scoreboards. We can try to show the scoreboard what if everything is solved. It doesn't.
Can we do that?
We can try to do that if Peter succeeded. There is some button like optimistic scoreboard. You can try to enable it and show what would happen if every submitted is correct. Well, not really every, but last submission on each yellow.
Every single pending submission is correct.
Well, not every single, but if question mark 5 is in fact +4.
Okay, yeah.
So, and we see what's happened next.
In an ideal world, yes.
Yeah, everyone succeeded. It's
yes.
What can be better. So we probably would get it at some point. Let's try to check it.
I'm actually excited.
What's going on at this point? Something interesting is going on, probably. or maybe it's just not working. We'll try. Well, probably. Well, if not, then it's not. We can try it next year. Well, not yet. Well, okay, next time. But generally, we have two teams which are claiming 9 problems, which is already good. So I think there won't be much intrigue on the first place, but definitely there would be on the second place. Nothing is. I have no ideas who would be the second right now.
Yeah, they haven't really solved much.
It can be, I think, any team in top 5 have a quite a good chance. I think we have the next guest. So thank you a lot. It was nice to meet you.
It was very
you can
nice to
catch
talk
me
to you.
after the stream about some activity.
For sure.
Amsterdam.
Okay, yeah.
Thank you a lot.
Have a good day.
So we are waiting for our next guest. And well, as I see by your T-shirt, you're not from this contest, but from another contest. We're not, which happens today in the same place. We're not really covering today, but still. So can you please introduce yourself?
Yes. My name is Marcel Vlastuin, and I am an organizer of the Dutch Olympiad in Informatics. And I'm also involved in the organization of the contest we do today parallel to the BAPC, the BXOI, which stands for the Benelux, of course, Olympiad in Informatics.
So it's Olympiad for several countries, like some local countries like IOI, but for 3 countries. So, and this is competition for school children, not for university.
Exactly, secondary education.
Okay, so so is it some beginner level, or it's which level of students?
Well, this is high level.
It's a high level
because
it's
this is more or less the kindergarten for the BAPC. Only they are not that old that they attend universities.
And also I think it should be a part of IOI selection team. So are you involved in preparation of Netherlands IOI team?
Yeah, also. The IOI was in Indonesia. That was about a month ago.
I think a bit more. I think it was in August. I'm not really sure, but I think it's more like 2 months ago. But
I think it was about a month ago.
Doesn't really
maybe
matter.
2 months. Yeah, it depends each year. Each year is different.
Doesn't really matter.
Sometimes it's in the winter.
Okay.
So, it could be 4 weeks, could be 6 weeks.
Well,
but
that doesn't really matter.
But we are in a new season, and this is the third Olympiad they are going to do. The second one will be the national ones for the Netherlands, but also for Luxembourg and Belgium. And in the spring, after we have selected the 4 IOI contestants, we are going to do a West European Olympiad in Informatics, which will be held here in Eindhoven. That's quite new.
I never heard about this contest.
It's the first time we organize it.
I heard a lot about Central European one.
Yeah.
And so it's like Central European, but West European.
Yeah. Yeah, you have the one in Scandinavia. And for the last 4 years, we had the BXOI, because there was a lack for Belgium and the Netherlands.
So which countries will participate in it? So which countries will participate in the new contest?
10 countries, Ireland, Great Britain, of course Luxembourg, Belgium, Netherlands, France, Portugal, I'm not sure about that one, Spain, Italy, and maybe Switzerland. And maybe we invite others as well.
Quite a lot of countries.
Yeah. Well, the ones that don't have a COI or the Scandinavian one.
Well, there was some difficulty. I think there was a Baltic contest.
Yeah, that's the
also
one. That's the one.
So that's a lot of them.
Yeah.
It's really nice. Like, in school, probably in school children have kind of more time for that, because in university you need to study probably a bit more. But not really sure.
I don't think so. I think it's easier for our kids to participate in this one. They're smart kids, so they don't need so much time to prepare for their exams. Maybe they find it hard, but I think this but that one is much easier for them. Yeah, their average score is 8 or higher in general.
How it work here? Do they get some advantages in their university? Well, they entering university if they have shown good results, or not really?
No, not really.
So it's just for fun and for love to solving problems.
Well, not always. Some students try to be in the top of the IOI, and they are invited for universities abroad.
I think you had a gold medalist in IOI a couple of years ago.
Yes, 3 years ago or 2 years ago we had Marco.
Yeah,
he got our 4th medal, and he's in Barcelona now.
Yeah,
studying there.
So he's in Harbor Space University, I think.
I don't know the name.
Okay.
Another one is Jelle van den Hoof, but he won the BAPC. In his first year he attended the BAPC. And he got a gold medal as well. That was in 2009 when the IOI was held in Bulgaria.
Yeah, that was quite long ago. But well, so what you are working with mostly school children, or you're preparing university students too?
No, we don't. I teach physics, but I got involved in informatics, because of the fact that I like programming. But I'm more interested in informatics than in physics, if it's about Olympiads.
Well, physics Olympiads can be quite interesting too.
It is, absolutely.
Like, I've participated in some low level in my when I was in school. I think the last one was in 9th grade or something like that. And so, all this experimenting stuff is it's really different from everything you are doing except that.
Yes.
Oh, by the way, I want to mention that our top team had a 3rd submission on problem A, which means that probably the second one was incorrect. Mm-hmm. And they're still working on it.
Yep.
So at least we'll probably will not have intrigue on if they win, but at least we have intrigue if they solve all problems. Why do you think that competitive programming is significant? Why do you think it's useful for children? What do they teach with? Why do you think that teaching that is good?
It's an interesting question. It's a hard question too.
What skills do you think are useful for them?
I approach it from a little bit different way. Out of the 10 students, 2 are going to do a beta study in the university, and that is too little in the Netherlands. It should have been 4. And what you are missing basically are the girls. And if you have all the girls doing informatics as well, you can solve a lot of problems in this country.
Yeah, that's a good approach.
A motivation. Then I turn it around a little bit.
I think that there was some special input for girls, like there was European Girls Olympiad in informatics.
Yeah, the closing ceremony was this morning.
I don't remember when it was.
Well,
I think
it was held over the last week.
Oh, okay.
In Turkey.
I remember that it was held in Turkey, but didn't remember when it was.
They're on their way home back now.
So how are they? How good? Which result did they have?
They were in the bottom half.
So
there's absolutely work to be done.
Oh, that's nice to have it. Yeah. So probably at least starting this work is already important. So probably I hope you would be able to do that. Mm-hmm. So at least I think that first of all, that people need to love problem solving, and when that part is done, then otherwise it's technical stuff, which is easy if you have enough time.
Yeah, it's hard to say what interests them. Most of them are fond of solving problems and doing puzzles in general.
Yeah, that's the main thing, I think, not the results, by loving to solve problems.
Well, sometimes the results are more important, but it starts with...
it really depends on the people.
Having interest in puzzles.
Yeah. It really depends on the person.
Yes, exactly.
Well, it was nice
to meet you.
Okay.
So
Nice to talk to you as well.
So maybe you want to add something. I saw some scoreboard, some results on your laptop.
Yeah.
So do you want to talk something about them? I don't know. Is the results of today's competition?
It's today's competition.
Okay, probably then they shouldn't be real.
Yeah, we are busy now with the medal allocation.
Okay.
And but the scores are still changing at the moment.
Oh, so your contest is running right now?
Yeah.
And it
will
finish
last for
at the same
another 30 minutes.
Okay. Oh, so it's finished in a couple of minutes.
Yep.
That's nice. Oh, that's well. School children Olympiads are different. Like they are both different in kind of set of problems.
Yeah.
And, so I've prepared a lot of school problems, but I mostly did it before 2016, and mostly didn't do that after it. But that's always interesting.
All right.
So, okay, thank you a lot.
Yeah, thank you very much. Okay, and I go back to my contest now.
Yeah, so probably when your contest is finished, it's a lot of work you need to be you need to do.
The work starts.
Thank you a lot.
Okay. You're welcome.
I'm not sure if we're getting anyone else, but we can check the scoreboard. Check what's happening in scoreboard right now. We have a lot of submissions. So we have 2 submissions, or 3 if something went wrong on problem A with University of Delft, which is claiming to solve all problems. Well, and we have a bunch of teams which are claiming solving 9 problems. And is there anyone who thinks that it's 10? I think I don't see it, unfortunately. Okay. So, and maybe we can check on which problems teams are working now by checking the statistics. So 4 teams submitted A and we don't know if they succeeded. So what we can see here, like green teams are the ones who solved this problem before the freezing, while red one is the ones who tried to solve before the freezing and didn't attempt during last hour, and yellow ones are those who attempted on the last hour and we don't solve them. So they can both come red and green, and I hope most of them would come green. It would be really nice. So on each problems we have a lot of submissions. And so do we have one more guest? Yeah, we have more coaches who can join us and discuss their teams and maybe some other teams, because I don't know much about different university teams. Okay, so can you join us? We can probably we have one more chair for you. I think it would be better to sit here, and we have one more microphone. So you can use headset to hear yourself. It would be a bit easier to adjust how loud are you, but so I can lend it.
It's
to
fine.
you.
Yeah, no,
Okay.
Thank you. Great job, by the way.
Okay, thank you. What university are you from? Can you please introduce yourself?
Absolutely. From Groningen. I come from the University of Groningen, where we set off at around 5:40 this morning.
Oh.
But we managed to come here on time, so something we are very happy about. And yeah, we have 5 teams, and we're excited to see how they've been doing so far till the frozen scoreboard. So yeah.
Oh, let's see. So did they submitted something in the last hour? Like, don't see. So it's a university which one is?
So number 11, for example.
So it's Rook. So these abbreviations are hard for me. Sorry. So you have team with. I see the team with 4 and probably one team within medals, which is really good result here.
Yeah.
Okay. So and one team's attempting on their 3rd problem. So well, the teams on the 11th place they're trying to attempt A, which is kind of hard problem. And both L, so they attempted on 2 problems.
Yeah.
So if they solve both, they would be quite high.
we'll be very happy. But I think yeah, it's I think a very good.
But even
effort,
accepting
good round.
either of them
Absolutely, yeah.
would
Yeah.
bring them up quite a lot.
So this is following. We've had a bit of a resurgence in competitive programming in the last year at Groningen. We've started up a course for introducing to programming contests, and we have a student committee as well.
Yeah, exactly. I think the study association.
What a student committee.
It's a committee of the study association.
Can you please bring a bit up?
Speak a bit louder. Or okay. So okay, yeah. Now I hear myself. Yeah, good. Yeah. So the study association cover has a programming committee that organizes programming competitions and facilitates the contest environment for Groningen.
That's really nice. So the teams can practice more. Well, by the way, maybe you can tell me something about that. Some time ago, when I came to Netherlands in April, I tried to search on code forces and find people from Netherlands, and find quite not really many of them. Why?
Yeah. So I don't think it's a very competitive country.
It's a burning question.
About it,
you have the answer right
so, to my knowledge, the Netherlands is not very a country where you do a lot of extracurricular stuff, like in a very like standard way. Like not a lot of people do a lot of extracurricular stuff. So things like code forces are only, I think, done by people that are actually really interested in competitive programming. And of course, we have things like BAPSI, and those people might participate in code forces to practice, but other people probably won't do things like that.
I fail to find a lot of students who participate, who preparing.
That is odd.
To me.
Yeah.
Maybe I've just not really tried hard enough, or maybe they just not saying where they're
coming from.
Quite easy.
Yeah.
But okay, so do your teams participate in this? Do you know?
I think they do. I think we have a Discord channel where they communicate, and I think they were talking about code forces and solving problems there.
Not only the code force, but any other regular contests.
Any of these contests.
Yeah, it might be
right?
Caddis as well.
Okay, well, I think that it doesn't really much on what exactly you do solve. You just need to solve regularly, which is important.
Yeah.
So, how long are your teams already participating, especially the top one?
So, I think there was last year. It was quite a scramble to get everything ready. So we were quite. Maybe we started preparing in the last moment, and yet we managed to find 5 teams who took part, and they enjoyed the experience. And this time we had a preliminary where there were several more teams for selection, and based on that we have our teams participating here. So I think we're on the upward trend. We're seeing more teams taking part. Next year we hope for even more, right?
Exactly.
Nice.
Yeah.
And that's how it works. Like when you have many teams, they are talking to their friends and, hey, that's cool, that's interesting.
Yeah.
And when you have a lot of people who are doing that, you get even more people who are doing that.
Building the culture, right? Which is takes some years, I think. But
it takes some years, yes. That's true. So I don't think we have any really interesting submissions, but at least we have submissions in medal zone. So something is happening. We don't know what exactly.
But is this frozen? It's frozen, right?
It's frozen now. It shows also. So yellow submissions can be correct. We don't know.
Aha, I see.
So unfortunately, we are not able to see what if scoreboards because something is broken.
Yeah.
That happens.
Yeah.
And I'm not sure about the amount of submissions of Delft University team because I think we didn't receive any submission when it's become frozen accidentally, but someone says that it's become frozen because they submitted this and they submitted last team, so scoreboard is frozen now.
I see.
But I'm not sure what's exactly happening, but probably that's not really important.
Do you think Delft will solve 12 problems?
I don't know, but they had one more submission, so probably they didn't done it yet. Or they're just trolling.
Exactly, they're keeping the tension high.
That's possible too. So problem A requires quite a lot of work. So we'll see. It's made. We need to know. We need to make people to come to the resolver. So
Yeah.
Why would you come if all problems are already solved? But I don't know.
That's true.
Something is interesting until the last moment.
Fingers crossed. Yeah.
So
Maybe there is who knows, a big change of order in the last hour.
Right, that
I
could definitely be
think
the
there
case.
can be quite big changes. Like we have all teams who solved 7, I think, have submission 9 problems.
Sure.
So in these 4 teams, anything could happen. It's quite familiar. Like maybe some teams with 6 can solve 3 problems.
Indeed, yeah.
It's not impossible. So
Right. No one got up to 11 yet, right? So even
I
with
think the first place is
pretty
yeah,
clear,
it's pretty clear. Yeah.
undiscussable. But anyway,
How have you managed to keep up this energy for 4.5 hours? This is
hard.
why I came here. We agreed to come here because we wanted to find the secret.
it's kind of hard. That's not first time for me.
Is it? Okay, I understand that.
Also, I was able to rest several times a bit.
And you trained for it?
Not really. But well, the hardest part for me here is English. Like,
Right.
it requires some effort.
Oh, fantastic. 4.5. Because we saw you at the very start. And now we'll be seeing you 20 minutes to the end.
That's okay.
Fantastic.
So at least when some judges were talking, some other people were talking. So I have some water. Water is great.
Helps you out, right? I mean, I know like for other competitions where there's a lot going on, you have a lot to talk about, but for
Yes.
like
so
you only see the submissions here.
probably that's the
difficult,
first
yeah.
stream when I'm just working as a host, but I quite often come to the stream as a guest and talk like for around 1 hour or something with about different stuff. Also on world finals. And
Mm-hmm.
that's some kind of experience, but
Yeah? Okay.
that's not the hardest thing to train to.
Sure. Okay, good. Well, it's been fun.
Yeah.
So I can tell you, Matthias here, so 4.5 hours ago, I think the broadcast started. And Matthias here has been glued to the TV since,
Yes,
with maybe a few small breaks, he's been glued to the TV since that moment.
Yes,
Of
well,
course. I'm only watching this actually. Yeah.
that's
Didn't even
quite
watch the
cool. That's
scoreboard,
why we're
so-
trying
Yeah.
to do
No,
that.
it's fantastic,
So
yeah.
I come here because we're doing that on world finals.
Oh, wow.
And we need to test our stuff, and we see that it's not working perfectly. Like we failed to open the optimistic scoreboard. We have some strange stuff with submission of the top team. So I'll investigate it after. What's
Nice,
going on?
Technical test as well, basically.
Yeah, well, it's one of the reasons, and
Right, yeah.
also it's quite interesting for those who know them. Unfortunately, we are unable to stream it publicly because of the contest in a week, which was announced
okay,
on. But still, even publishing it for coaches, for team member parents would be quite nice because
Yeah, it would be fantastic.
probably we can a bit unwrap it for some family members of teams because it's always a problem like what you're doing,
Yeah.
what's going on, and I tried to explain it. I think we have more people who
Fantastic.
want to say thank you a lot.
Right?
Thanks a lot.
Then we'll
Thank
leave
you.
the stage.
So-
Good luck with the last.
So we have last
20 minutes, yeah.
with a lot of
Almost there.
submissions and more coaches coming to want to talk. So, hi. Could you please introduce yourself?
Hi, I'm Thomas Verwoerd. I'm coach of Delft.
Oh, your teams are participating very well today.
They're doing pretty well. Yes, we're hoping up on the same results like last year when we were first and second. And yeah,
Not sure about first and
second place is gonna be hard, but
at least
I-
you.
I-
But
I-
I think I think you should get at least 2 or 3 gold medals. Which
that will be a great result.
even if it's first, third, and fourth, it's still good.
Yeah, absolutely. So yeah, I mean, I'm still curious if they're gonna finish all the problems like they did in the preliminary contest for Zegveld Gosbreu, and yeah.
Oh, we'll see what's
Yes,
going
I
on.
mean, they did it. Yeah,
So,
they're the only team to do it in the preliminary contest.
So, do you think they would be able to solve A? They had
Well, I was not able to, so I never guessed how it should have been done.
okay.
But I hope so. I mean, I'm
Well,
optimistic.
It's definitely solvable.
Yeah,
At least
absolutely.
a couple of your teams did this.
So, yeah.
So I think that the only Delft University team succeeded in with problem A before the freezing.
I mean, the other
So the third place and the fourth place.
Yeah.
did. So probably they can too.
So, I mean, every time you see a submission come in, you hope that it is the correct one, but yeah, every next one, it was wrong.
Well, but when you get next one,
yeah,
which can be correct.
exactly, yeah. I mean, and it's. I think the first place is they have a good chance of winning that.
Well, they have.
I mean,
good chances.
they got some competition left, but you never know what happens in the last 15 minutes.
Well, I don't think they even have a competition right now. I think no one claims 11.
If they solve, one team solves all 12 in the last 15 minutes,
Yes,
and they don't solve 8, then they're beaten.
But I think that in current point, no one even claims 11.
Yeah.
So that's not really probable.
It is not, but
it's
not a guarantee.
No.
Yeah, that keeps this contest exciting. In the last hour, when you don't know what's happening, you start imagining the craziest idea, because then your team might even have a chance on getting to the World Finals, or they may,
Well, this happens sometimes. For example, personally, I have solved 4 problems last hour in one contest.
Yeah,
that happens. That's not common, but it happens.
It happens, yeah. And never.
So and Utrecht University doing their work too. So they're trying to solve L. Not sure which submission it is, but anyway. So
I mean, and the number 3 team. Also, don't underestimate them.
That's a strong team anyway. So, what's making your team so strong? Why they are much better than others? Some secrets?
It's always hard, because if you look back at the scoreboards from 5 years ago, we were always in the bottom half of the scoreboard as Delft University. And actually, in the last 2 years, we got an influx in international students, and that actually added a lot of teams that are participating in IOI already, joining in our first year's contest, joining in the DAPC, the Delft Algorithm Programming Contest, our preliminary. And they got, they were really good. And that's always nice to see. But we basically only gave them the option to show that they're really good, but never told them how to be really good.
Having ability to people to find each other is still very important.
Yeah, absolutely.
That's already a big work, and it's really important.
If you look at the team Ada Refactor, which participated by herself in our preliminary, and we actually made a new team out of it for 3 people. And they're still doing very well.
Well, helping people meet is important.
Yeah.
So, I think that you was participating in the last year World Finals. There was some
I was coached in the World Finals in 2012 and 2014.
Okay, I'm missing. Yeah, I understand which I'm missing for, and probably I'm not sure. I think you have some medals even on the World Finals a long time ago, in around 2004.
No,
I'm missing with some other university.
We were 3rd once in the World Finals of 1995.
Okay, I think
that's a long time ago.
Yeah, I think there was something.
That was in the time that the World Finals were 40 teams.
Well, I think there was something around 2004, but I'm not sure.
2004. No, that was the University of Twente.
Maybe.
I think.
Sorry, I'm not really well in. I can be messing between them.
It was,
Okay. So, so we have 10 more minutes. There's no more submissions yet, so maybe it's the 3rd one.
Maybe they're programming, and last time they programmed, when they were done, they were programming on Pong on their machine. They were playing their own written Pong in the last hour, just waiting for the contest to be over.
Well, I don't know if you really need to wait it in that case, but okay. So, and what are your other things? Maybe what you can recommend to other coaches, like if you are doing so well. So the secret is just to help people to meet.
Help people to meet and help them, ask them what they want. It's and yeah, it's basically I make sure that your teams can get to contests. I always make sure that even if like the Hamburg is like all the way in Scandinavia, that we made sure that we had funding from the university, that we had hotels, that we just could fly there and be there with the teams, because part of winning the Porsche is to actually experience the contest. And that is, I find, always the best motivation for your teams to actually want to train, want to get further into the next bigger contest, which is even more amazing than the previous one.
Yeah, that really helps because, for example, World Finals, it's a great event.
Yeah, absolutely.
Except all the abilities, like you have work approaches and stuff like that. It's just a great event which is interesting to participate in.
Absolutely.
And that's a great motivation for a lot of students. So, and to check this, you need to show maybe some local events like preliminaries.
Yeah, well, yeah, we do preliminaries. We have a special contest for our first years. We do in May, where we have a shorter contest of 3 hours, where we create problems for simpler problems, but actually to let people experience the contest.
Yeah, that's big stuff because starting is always hard.
Yeah. Not everybody has some people who participated in the IOI. That's, for example, the SECVOLs. Some of the contestants participate in the IOI, but some people only know about programming contests when they start university and then immediately go into the ICPC style.
Well, I know people who started at university and get to the great results.
Absolutely,
it happens.
But you want to know if you like it and want to work for it, because you can't win a contest by not doing anything for it, of course.
Yeah. So. Well, it's work, but first of all, you need to love to solve problems.
Yes, absolutely.
That's the most important part. Okay, so we have 10 minutes to the end. I'm viewing the list of submissions, but don't see any from any of top teams for a couple of last minutes. So, but I think there are always a bunch of
you always have
last-minute submissions.
Try or die submissions.
Yeah, just try anything.
Yeah.
Try to some.
It's probably wrong, but it might just get through.
Well, maybe some hacks to trying to hack some jury test data instead of solving problems, which is always nice.
Print out a nice logo. People always do that.
Or just, I don't know, submit all problems to make Resolver more interesting. I don't see any team which did this. It's strange for me.
We still have 10 minutes for that.
Makes sense.
It will happen in the bottom of the scoreboard, I expect.
Well, it's happened in different parts.
Yeah.
I always remember sometimes
there is one team that submitted all the way at the top that submitted everything, so
well, I think
it already happened in that sense.
Well, I think that sometimes it's happened. I remember some funny situations like the team which really solves like 3 problems in the last hour, after that submitted all. And you say, hey, they submitted all, they probably did solve nothing, and they did solve. Yeah. But not everything, but at least something.
I remember the story. This happens in the BAPC of 2012. One person participated by himself, and he was really good. He went to the World Finals the year before, but his team broke up, so he participated by himself. And he didn't submit anything, and then just after the freeze started, he submitted everything.
Well,
and
why
had
not?
mostly everything correct as well, except for the easiest problem, because he made a typo.
Okay. Well, that's not a good strategy in sense of penalty time.
It is not, but he actually did win.
Oh, okay. That's a plan.
Yeah, it's a plan, but it's
not showing other teams which the problems are simple.
Yeah, I mean, you can always start with the hardest problem and put everything off the trail.
Yeah, that's.
If it works, it can pay out. But
well, to be honest, it can happen unintentionally when one team is much stronger than others.
Yeah, or you
have a lot of problems which are equally easy to you, while not equally easy to other teams. Also, maybe we can show the company's scoreboard. There another contest we did not check much. We didn't check it much, but it's still at least have a look. Sorry. Okay, but having a look of its final scoreboard would be nice.
The post-freeze scoreboard, yeah. But how was your experience for the contest today?
Well, it's really nice. I think I really love the problem set. It was quite good and interesting. I think that it was quite on the level of his teams. Maybe a bit easier than it should be, but you never knows.
Yeah.
But at least for the top teams, but still, so it's predicting hardness of problem sets is really hard.
Yeah, absolutely.
So you can't really guess which problem is easy, which is not, and it's really depends on scoreboard and a lot of other stuff.
A good problem set is if the last team didn't solve anything, they only solved all problems in the minute after the contest ended. It is a good problem set, but if it's a minute earlier, it's like was it difficult enough?
Yes.
So it can be
So well, even if the Delft team succeeded in the last problem in like 20 minutes before the end, it's okay. It's not perfect, but quite okay. But they submitted G. Why not?
Wait, it's like they
submitted.
They already solved G, right?
Yes.
Yeah.
Maybe they tested some time limit stuff.
Yeah.
So maybe they just doing random submissions because they can. Maybe then testing.
Maybe they gave up an A. I don't know.
I'm not sure if our scoreboard is ready for that. Okay, so we can't show juries. We can't show team company scoreboards. That's okay, but we can check if my soft is working correct. The submission on the already solved team.
Yeah,
probably it should. I hope. So, but anyway, they're testing something.
Yeah,
not sure what does it mean.
But they moved off of A, so I don't know what that signals.
Well, I don't think they moved from it. They just testing some time limit stuff.
Yeah.
They wrote something, they receiving time limit, and want to check on problem without getting extra penalty.
Yeah,
which is nice. Always nice not to get extra penalty.
Absolutely.
So can we check the scoreboards of this contest if we are able to show the? Maybe they didn't. The green didn't get yellow. That's good.
Yeah. That happens if it's wrong, then it gets yellow, or
no. I just didn't have a right successful submission by unknown submission. I'm happy I'm not having a bug. It's always nice to test your code, especially when the testing is done by others. By the way, we have one more guest, so it was nice to meet you. Maybe you have
nice,
some final words.
For having me here, and good luck with the last part of the broadcast.
5 more minutes.
Yep.
Okay, so I think it would be the last guest here. Yes. And can you introduce yourself?
Yes, hello. I'm Jaap. I'm here kind of as a guest, a weird state, because I'm both from Booking.com. We have 2 company teams here, but I'm also one of the developers of the system, the contest system DomJudge that is being used here. So I'm also in that behalf here as well. So I've been looking around. Might have helped a bit. Actually, it didn't need any help because everything was running smoothly. So
that's perfect.
It's been a very quiet day, actually.
So probably that's another test for the World Finals. Does it use DomJudge this year?
Yes, we'll have DomJudge indeed again as the primary system at the World Finals. I think this year PC Squared will be the shadow system. So maybe it's good to kind of maybe for people who kind of don't need, maybe can tell a little bit about like the whole setup that we have there and that we test here as well.
Well, okay, so probably you can tell about this more than me. I'm not
really
sure.
I think you know a little bit of it. I think since many developers from DomJudge, the programming contest system that we use here, are from the Netherlands or this area, we tend to use this and also the Northwestern European region as a testing grounds for the World Finals, where both DomJudge and also Catis, which is another system, contest system.
So just for the contest, like their testing system where participants submitting their sources, there are a lot of these testing systems. Mm-hmm. And when you have a really serious contest, you're just not having one testing system, but having two cross checks, backup plan. Like if something went terribly wrong, you can fastly switch to another one.
Yeah,
you probably can.
I mean, that's the goal a little bit. I think the primary reason is that it's a very good validation system where because every system has its own peculiarities, how it works, and maybe it could have a bug. So basically, what we do is we run two systems at the World Finals. One is the primary system that does all the main work and everybody interacts with that. And then there's a secondary shadow system that people don't interact with. And all the submissions that get submitted, they get forwarded from the primary to the secondary system. And basically the secondary system just does like judges them like as well in the same way. And then we compare whether the shadow system actually gives the very same results as the primary system.
Well, it can get a bit slightly different results.
Yes.
Well, I don't know, the submission is on the border of time limits or something like that.
Absolutely.
How you deal with it?
So over the years, we've built more sophisticated tooling for looking into that. So nowadays we have both the systems. We have like a sort of a difference matrix that we can easily kind of look at. And sure, there's always going to be submissions, like you say, that like where a submission is very close to the time limit of the problem, and then maybe even though we run on the exact same hardware, it's just random fluctuations. So sometimes it may just be above or just be below, and there's going to be a difference. But those are typically, I mean, it's easy to investigate. So basically, what happens?
It's single submission, or like couple of submissions during the contest, which
think
you can investigate manually. And check
yeah,
what's
I mean,
going
I
on.
would say at the World Finals, we typically have, like, we have 130 teams. We tend to have around like 2,000 submissions in total. I think there tend to be on the order of 10 to 20 submissions that actually have differences.
Okay, that's
I mean,
not too much.
Yes,
That's
I mean, it
definitely possible to handle manually.
Yes. It used to be a bigger number in the past, but I think that's also because I think as a result of doing this, we've now been doing this for I think almost 10 years. So the very first time I think we did this was in, actually maybe a bit of history, was in Warsaw in 2012. Yes, right. Yeah, and but it was more coincidence because actually we were then invited, being part of like the same what you're now doing, like what you're doing, the whole sort of live presentation, and we thought like, hey, we'd like to have be able to look at submissions and see like, hey, are there bugs? Why are they kind of certain submissions wrong and so on? And we couldn't use the main jury system, so we said like, well, let's just use Dumb Judge, and actually let's just sort of like screen scrape the submissions from the main system, and that was okay, or actually take them from the HTML from the main systems pages. And then we ran into all kinds of weird differences because of different compiler settings or different. Are we running out of time?
Contest is over now.
Okay.
But we can speak for like 5
so let
more
me
minutes.
and then we found.
Let's show a scoreboard for.
Let's quickly show the scoreboard.
Yes. So what do we had at the end? Like we have Delft University with 3 submissions on problem A. We have Utrecht claiming 11. And probably with definitely worse time than Delft has, so they're not claiming the first place, but 11 is a great result, especially if Delft will not solve 12. And we have some more teams, I think, claiming 11. No, not really. But no one knows what did they really solved. So there are several teams that are claiming 10 and 9. So, well, I think second place is totally unclear. Like, everything can happen. We'll see what. So come on to the stream with resolving. If you are messed into it, it should be interesting.
Yeah. Did you, by the way, talk about like maybe to people who are here, like the resolving that we'll do?
I think that person who doing the resolver, I talked a bit, but the person who will do the resolver will explain.
That's true. Yes. Okay. Yeah. So
yes,
let's see.
It's funny reason. I think now a bit slight that you have 2 systems. I think you have at least 4. But because system for analytics still exists, and I think it's separate for main and shadow one.
Yes, but it tends to be the way we do it at the World Finals is that the same team who runs the shadow also runs the analytics system.
And also a system for
the online contest.
For online contest.
Yes, yeah. So yes, there's different systems, but there's typically only 2 teams. Like it's different copies of the same 2 systems. Yes, tends to be
a bit easier.
Yes.
Having real too. So
yeah.
So nice to meet you. Probably we'll meet again in Tracker.
Yes, and let's hope that this was I think this was a very smooth test. How was it also for you? A good test?
Yes, it was a good test for both of us.
Okay. Yeah. No. Yeah, that's always. I think also this contest.
And what maybe you can say about this strange feature about freezing when the team submitted last problem?
Maybe okay. I think maybe I can reveal a little bit. Like I mean, I've been in the jury room. I think the reason was that they felt like if that team would have solved the last problem, then it would have sort of made the whole freeze like kind of pointless, or I mean not entirely pointless, but then so I think they wanted to keep some suspense, and for that reason they froze the scoreboard ahead of time. Yeah.
Okay. So, but I just didn't see the submission. I'm interested in if it's CDS bug or my bug or what will.
No, yeah. Oh, sorry. Yeah, no. It was like
We'll investigate it later.
It was intentional. Like sort of the freeze was intentionally a little bit earlier than normal.
Okay.
Yeah.
We'll investigate it later. There's something probably. So thanks you a lot.
You're welcome.
We'll finish our stream at that point. Please return to the stream with Resolver. It should be interesting as the closing ceremony itself. And thanks you for watching. And thanks. And can we show Peter? Can we show you the guy you don't want? Here is Peter.
I will just join you guys for one moment very quickly. I've been sitting there most of the afternoon arranging this entire stream. But Pavel, I really want to thank you. You did an amazing job in sitting here all afternoon, speaking with everyone here. Really, you did a very good job. Thank you very much.
Thanks to you too. But because of all this video production stuff, it won't be possible either.
Thank you very much. It was very nice to produce.
Thank you. Okay. So we'll